Chancellor of Mangalore University, Professor H.S. Nagendra Swami Sir, Chairperson of the Department of Studies in Computer Science, University of Mysore, Professor B.H. Shekhar Sir, FDP Convener and Professor in the Department of Computer Science, Mangalore University, Mr. Prakash M., Assistant Professor, Department of Computer Science, Mangalore University. I am Dr. Bharati Pillar from University College, Mangalore. Hereby take this opportunity to welcome you all. I now request Professor B.H. Shekhar, FDP Coordinator, to escort the dignitaries onto the dais. Recently, there has been a significant surge in the development of artificial intelligence, especially in the medical field. AI has played a crucial role in transforming medicine, and deep learning models have been pivotal in advancing medical image processing. These sophisticated techniques have transformed the way medical professionals analyze and interpret various types of medical images. Hence, FTP on deep learning techniques for advancing medical image processing is highly relevant in the current scenario. Before we begin, let's invoke God's blessing through prayer. I invite Ms. Priyanka, Ms. Devika, Ms. Shreya Shri to lead us into prayer. I request all of you to kindly rise.
ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ವಿನಾಯಕ ವಿದ್ಯಾದಾಯಕ ದೇವ ವಿನಾಯಕ ವಿದ್ಯಾದಾಯಕ ದೇವ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು ಪಾಶಾಂಕುಶಧರ ಮೂಷಿಕ ವಾಹನ ಸರ್ಪಾಲಂಕೃತನೇ ಗಜಾನನ ಪಾಶಾಂಕುಶಧರ ಮೂಷಿಕ ವಾಹನ ಸರ್ಪಾಲಂಕೃತನೇ ಗಜಾನನ ಆದಿಪೂಜಿತ ನೀನು ವೇದವಂದಿತ ನೀನು ಆದಿಪೂಜಿತ ನೀನು ವೇದವಂದಿತ ನೀನು ಮೋದಕ ಪ್ರಿಯ ನೀನು ಗಣಾಧಿಪ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು ಗಿರಿಜಾಸುತನಿಗೆ ಗರಿಕೆಯ ಸಲ್ಲಿಸುವೆ ಪರಿಹರಿಸು ಪಾಪ ಗಣಾಧಿಪ ಗಿರಿಜಾಸುತನಿಗೆ ಗರಿಕೆಯ ಸಲ್ಲಿಸುವೆ ಪರಿಹರಿಸು ಪಾಪ ಗಣಾಧಿಪ ರಕ್ತವರ್ಣನು ನೀನು ಲಂಬೋದರ ನೀನು ರಕ್ತವರ್ಣನು ನೀನು ಲಂಬೋದರ ನೀನು ರಕ್ಷಿಸಿ ಕಾಪಾಡು ಗಣನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ವಿನಾಯಕ ವಿದ್ಯಾದಾಯಕ ದೇವ ವಿನಾಯಕ ವಿದ್ಯಾದಾಯಕ ದೇವ ಶರಣು ನಿನಗೆ ಶರಣು ವಿನಾಯಕ ಶರಣು ನಿನಗೆ ಶರಣು
Thank you. We have with us Professor Sharmila Kumari M., Vice Principal and Head of the Computer Science and Engineering Department of PA College of Engineering, Mangalore. I request Madam to welcome all the dignitaries on the dais and the gathering.
A pleasant morning to all gathered here, respected dignitaries on and off the dais, esteemed faculty members, invitees, dear participants, research scholars, and ladies and gentlemen. I am pleased and honored to welcome you all to the inaugural program of Faculty Development Program on Elevating Healthcare through Advanced Deep Learning Innovations in Medical Image Processing. Great leaders exhibit courage, passion, confidence, commitment, and ambition. They nurture the strengths and talents of their people and build teams committed to achieving common goals. We have with us such an visionary leader, inspiring personality, Professor Jairaj Amin, Honorable Vice Chancellor of Mangalore University, as the President of this inaugural program. On behalf of all present here, with grateful heart, I welcome you, sir. Now I request Dr. B.H. Shekhar to florally welcome our Honorable Vice Chancellor, Professor Jairaj Amin. We feel incredibly privileged and honored to have with us Professor H.S. Nagendra Swamy, Professor and Chairman, Department of Computer Science, University of Mysore, as the chief guest of this inaugural program, as well as keynote speaker of the Faculty Development Program. He is an accomplished individual in the field of pattern recognition and image processing. I wholeheartedly welcome Professor Nagendra Swamy, whose journey is a witness to the fact that hard work, determination, and dedication can lead to great success. On behalf of all of us, I wholeheartedly welcome you, sir. Now I request our Honorable Vice Chancellor, Professor Jairaj Amin, to florally welcome our chief guest, Professor Nagendra Swamy. We have with us Professor B.H. Shekhar, Professor, Department of Computer Science, Mangalore University, and the coordinator of this faculty development program. Sir, your enthusiasm and efforts towards receiving funds from various funding agencies is really commendable. Your endless care, guidance, and support to the department, university, and all of us prove that you are a great motivator. With a thankful heart, on behalf of all present here, I welcome you, sir. Now I request Mr. Prakash, Assistant Professor, Department of Computer Science, Mangalore University, to florally welcome Dr. B.H. Shekhar. It's my proud privilege to welcome Mr. Prakash, Chairman in charge, Department of Computer Science, Mangalore University, for his support and encouragement to conduct this program. On behalf of all present here, I welcome you, sir. Now I request Dr. Pankaj Rahi, Associate Professor, Institute of Health Management Research, Bangalore, to welcome Mr. Prakash. Thank you, sir. We have been fortunate enough to be backed by a team of very motivated administrative authorities of Mangalore University, professors from various departments, dedicated faculty members, technical and supporting staff members from Computer Center and Engineering Division, led by Mr. Vijay, so who know their responsibilities and are result-oriented. With great pleasure, I welcome you all to this inaugural program. Welcome you all. We also acknowledge the gracious presence of Professor A.M. Khan, sir, Professor, Department of Electronics, to this program. On behalf of all of us, I cordially welcome you, sir. Dear participants, it's my pleasure to extend a cheerful welcome to you all. So your presence enriches this experience, and we are looking forward to a fruitful and engaging time ahead. I welcome you all to this program. I also welcome Dr. Manjaya, Chairman, Department of Computer Science, Mangalore University, and Dr. Shashireka, co-coordinator of this Atal FDP, in their absence. Once again, so I welcome you all to this inaugural program. Thank you.
Thank you, ma'am, for the words of welcome. We extend a warm welcome to you as well. Now I invite Miss Sharal and Miss Asha to florally welcome Professor Sharmila Kumari, madam. Deepam signifies knowledge. With a single deepam, we can light many more. However, the original lamp does not diminish when used to light others, signifying that our knowledge does not decrease when shared. The clarity and conviction increases on giving, and the giver and the receiver are both benefited. In order to significantly dispel the darkness, I now request the dignitaries on the dais to come forward and kindly light the lamp and inaugurate this program. Dear participants, we are fortunate to be part of this FDP, as today we embark on a journey of innovation, exploration, collaboration and learning, aligning with the evolving landscape of technology and healthcare. We got this invaluable opportunity because of the immense knowledge, hard work and dedication of Professor B.H. Shekhar sir. His tireless efforts have paved the way for a week filled with interactive and hands-on sessions by eminent speakers designed to enrich our knowledge and skills in this rapidly evolving field. I now request Professor B.S. Shekhar sir, the program coordinator, to present the theme and give us more insight into this program.
Good morning to all of you. Esteemed dignitaries on the dais, participants representing various organizations, esteemed faculty, research scholars, and the students. I stand before you to present a concise overview of this AICT et al. Sponsored faculty development program titled Elevating Healthcare Through Advanced Deep Learning, Innovations in Medical Image Processing, scheduled over the next 6 days. First and foremost, our heartfelt gratitude goes to AICT et al. For generously funding this 6 days faculty development program, and to our university administration for their unwavering support in organizing such events. Their continuous encouragement and motivation drive our university towards greater heights, aligning with our vision of spreading intellectual knowledge. The et al., that is AICT Training and Learning Bureau, has been instrumental with innovative ideas, consistently providing substantial grants to enhance the quality standards of faculty in engineering colleges as well as the universities. Recognizing that higher education is undergoing transformative changes globally, the National Education Policy of 2020 serves as our guiding light on this transformative journey. Quality teachers from a vital community capable of driving these changes and play a pivotal role in the development, sharing, and dissemination of the knowledge. So it aims to empower teachers through capacity building training and workshops, enabling them to identify, define, and implement necessary changes in the academic curricula as well as the research. The vision of achieving the status of global knowledge leader cannot be realized without the active involvement of a competent body of the quality higher education teachers. Each new generation faces a rapidly changing world with mega trends such as globalization, sustainability, and automation shaping our society. The skills required for education go beyond digital proficiency. In this context, we have submitted a proposal titled Elevating Healthcare Through Advanced Deep Learning, Innovations in Medical Image Processing, which is an advanced FDP. We have conducted a basic FDP on medical image processing basics, and this will be focused more onto the providing a knowledge, particularly in domain expertise, which is among the 150 proposals accepted out of the 1,264 applications. As you know, the evaluation criteria include course content, objectives, and the context, as well as the relevance through the journal articles, quality of the resource person, and also the impact and as well as the expected outcome. The chosen area is significant to meet present day needs. Our proposed FDP aims to provide in-depth understanding of existing machine learning as well as deep learning approaches to medical image processing. We plan to discuss architectural details of deep learning models and implementation issues, enabling faculty to undertake research in this domain. Mathematical details of machine learning algorithms will be reviewed to help attendees understand research work published in reputed journals. This advanced FDP aims to provide particularly domain knowledge. Therefore, we have invited experts, particularly doctors working in medical image processing domain. They will share their expertise in applying machine learning and deep learning methods for various disease identification as well as detection, in particular arthritis as well as the skin cancer. Our objectives include providing details of deep learning models suitable for medical image processing, discussing techniques for detecting various diseases, and presenting the development of algorithms that can handle factors like aging, illness, as well as the changes in their appearance. We have identified a top resource person from institutes of national importance, industries, as well as the universities. And today we are honored to have Professor H.S. Nagendra Swamy, Chairman and Professor in the Department of Computer Science, University of Mysore, Manasa Gangotri, Mysore, delivering the keynote on machine learning as well as deep learning methods for medical image processing, who will set the stage for this 6 days FDP program. Once again, I welcome you, sir. Our esteemed resource persons include Dr. Jenny Rajan from NITK Surathkal, Professor Yogesh Kamath, MD from KMC Manipal, Dr. Achal Shetty from Father Muller's Hospital, Professor Manjunath Chennai from Enapoya Medical College, Mangalore, Professor Pannappa from Mysore, and Dr. Dinesh from Samsung R&D as an industry expert. Our dedicated research team are supporting the practical sessions. In fact, the credit goes to all the research scholars of our department. So in fact, this is the effort by them rather than by myself. It's a team effort, and I should thank all of them on this occasion. In conclusion, we gather here to inaugurate this faculty development program, sharing the planned learnings over the next 6 days and expressing gratitude to those who contributed to this faculty development program. Thank you all for your support and active participation in this learning process. I wish each participant a very happy and pleasant day in our campus. Thank you very much.
Thank you, sir. The fragrance of the flowers spread only in one direction, but the goodness of a person spreads in all directions. We have amongst us such a humble and eminent person with diverse talent, who is none other than Professor H.S. Nagendra Swami sir, Chairperson of Department of Studies in Computer Science, University of Mysore. I now request Professor Nagendra Swami sir to deliver the inaugural address.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. Respected and Honorable Vice Chancellor of Mangalore University, Professor Jairaj Amin sir, my beloved friend and professor B.H. Sekhar sir, and my friend Mr. Prakash, and distinguished professors from other departments, Professor Asif Khan and Professor Sharmila Kumari madam, and also Professor Bharati Pilla, and the distinguished professors from other institutes in and around Mysore who are present here, and all the invitees, participants, and ladies and gentlemen. Good morning to one and all, and best wishes for the day. It gives me an immense pleasure and privilege to be a chief guest of this inaugural function, and also as a keynote speaker. Just now we have inaugurated the 6 days FDP program entitled Elevating Healthcare Through Advanced Deep Learning Innovations in Medical Image Processing. We have happily inaugurated, and we wish the FDP program a very grand success. At the outset, I would like to congratulate all the people who are responsible directly or indirectly in organizing this event. And my special thanks to Professor B.H. Sekhar for his dedication and involvement in getting fund from AICT in conducting this workshop. And also I appreciate the support extended by the administrative authorities of Mangalore University and everybody, the research scholars of the Department of Studies in Computer Science, Mangalore University, and everyone who have supported to organize this, this function, and wish the function a grand success. Dear participants and friends, we are all very much familiar that health is wealth. It's very much important that we have to maintain a physical and a mental health. If we are healthy, then we are rich. And anything else will become insignificant and unimportant when we don't have health. Hence, it is very much important to maintain the health for individuals' progress and the society, and as well as the nation. In order to maintain the health, we have a healthcare system, where in the healthcare system we have various entities like hospitals, doctors, practitioners, nurses, technicians, the patients, everybody is involved in a healthcare system. It's a very complex system. Then with this healthcare system, we can maintain the health, but still we understand that a technology is very much important to keep this healthcare system in a well-paced manner so that we can reduce many parameters which are involved in this very complex system. Because we understand that the data plays a very important and a crucial role in any healthcare system. Because the data which has been captured, if interpreted wrongly, that leads to very serious consequences. The data, definitely the source, and we understand the data is generated when a doctor interacts with a patient and records the symptoms and then prescribe the treatment to the patient. The data has been generated. And definitely when a patient is subjected to the scanning, like CT or MRI scanning or X-ray, the data has been generated. And when we understand this, it's very obvious that the data appears in the form of a text, the data appears in the form of an image, the data is appeared in the form of sound signals, and also the audio. It's very much important for us to understand all these modalities of the data. And it is very much important that we need to integrate it in a very precise way so that we can draw some good conclusions and that leads to a better treatment. And definitely we have to understand that in this process, one should understand the precise meaning of what exactly is the process. According to my understanding, the process P stands for the proficiency. Each and every person involved in this healthcare system, including the doctors, the technicians, and whoever is that, must be very much proficient. And also, the person should be responsible. R stands for responsible. The O stands for the orientation. And C stands for the commitment and the concentration. And E stands for the ethics and efficiency. S stands for the skill and the simplicity. And these are the very important qualities we must need in each and every person who are involved in a healthcare system. Suppose if any of these parameters have not been evaluated properly, then definitely the consequences will be very difficult or very different. And at the same time, it is very obvious that we cannot expect all these attributes everybody who are involved in this healthcare system, because we understand very recently that one of the doctors in a Bangalore Kidwai hospital was mentioning that they accept up to 35% of the error when they are diagnosing any pathology or any data related to cancerous. Then think of the error, 35% of the error. Suppose if the pathology doctor did not have a patience and a proficiency and orientation in analyzing the data and give the reports, then it leads to a very serious consequences, because many times we go for a second opinion. Why? And definitely in today's fast life, everybody wanted the result at a faster pace. So there is no patience. But definitely in case of a medical system, it is not like that. We should have a patience and we should have ethics in. So if you don't have those things, definitely it's very tough to maintain the entire system, because it's a complex system. And because of that, definitely we can provide to some extent a technology support where to a certain extent we can reduce some of the limitations what we are finding today in the healthcare system. And also we can enhance whatever the qualities we just now mentioned, that process. And in this direction, from the past few decades, a lot of attempts have been made, and the people have explored the applicability and feasibility of artificial intelligence techniques in a medical healthcare system. And a lot of significant improvements have been found. And very recently, the people have also explored a very specific field like machine learning, where many machine learning algorithms have been explored and successfully implemented. and that supports a very efficient results in terms of scanning, in terms of organizing unstructured data, and also getting results mined out of the data, raw data. So in all those directions, a lot of significant improvements have been made in the direction. And very recently, the people have still explored the applicability and feasibility of the deep learning techniques. The reason is very simple. Whenever we do a machine learning, definitely we need to extract the features, and many a time the features what we have extracted may not produce an efficiency result or efficient results where there is a error. Because many times what we do is we experiment on a particular data set and we report that the algorithm has shown 80% of the performance. But what about the remaining 20%, right? Being a person in the medical sector domain, for a doctor or a clinician, or anybody for that matter, it's very much important that where is the 20% of the error? Because that 20% of the error may lead to very serious consequences. Because we have seen many examples. My own relative, uncle, died because of wrong administering anesthesia. A healthy person get into the hospital, just a minor fracture in the hand, they just gave the anesthesia, but we don't know what is the dosage they have given. But we understand later that instead of 0.01, they gave 0.1. Look at the amount. And just because of that, the person get into the coma, and for almost 1.5 years, he was in the hospital. And it could not be reversible, because once brain signals dies, it cannot be reversible. So it's very, very difficult. Even very recently, when you had been visited to Kidwai Hospital and Nimans, even the doctors have come out to our department, just a collaborative work. And they were admitting that most of the times doctors go wrong in prediction, in analysis. And because of that, sometimes the patients are going to lose their life. And they have to, they will be subjected to very serious consequences. So because of this, is it possible for the technocrats, the researchers, and the academicians to look into those very serious issues so that we can do research and we can propose a very useful algorithms which assist the doctors so that they can take a quick decision at the right time. So early diagnosis of cancers, that's one of the very important area which has received a lot of attention, and a lot of attempts have been made, particularly the breast cancer detection, early cancer detections in throat and blood, and etc. So if we support the doctors with these advanced technologies, definitely it is possible for a doctor to make a correct prediction at the right time so that the patient can be treated well in advance so that we can save the life. And by doing so, we can definitely elevate the healthcare system to the next level, and also we can reduce the cost involved in the entire healthcare system, and we can give a better experience to the patients, and also we can share the information online in a real time, in a dynamic way. With a lot of such benefits, definitely the technology can revolutionize our healthcare system. But what is very much important is the role played by the major entities in this healthcare system, that is the doctors and the pharmaceutical companies and the researchers, academicians and technicians, of course the patients as well. With the support of all these people, with a lot of innovations in various domains, we can definitely meet our expectations. Maybe one fine day we can tell the society and the nation that we have a very good healthcare system supported by the technology. And with that, we can maintain the health to the maximum extent possible, both the physical and the mental health. And having maintained the physical and mental health, definitely each and every individual will be very, very productive, and is productive in its own growth and also in terms of the society and the nation. So a healthy nation is very progressive, and definitely we can see the wonders and of course the heaven in the earth when everybody is healthy in terms of their thinking, in terms of their action. So with these words, I'm sure that the next 6 days of this FDP program, as B.H. Shekhar sir has already pointed out, many eminent personalities, academicians, the technocrats from the industry, and the doctors are going to explain what are the challenging issues in a medical sector. However, these challenging issues have already been addressed, and what are the gaps still present, and how the young research and the technicians can look into that direction, and so that the gap will be filled, and that's how the young researchers can think of coming out with the creative ideas in solving a problem as a part of their research, as a part of their project. And with these things, I wish all the participants all the best, and the FDP a grand success. So I have a pleasant day. So thank you one and all. Have a good day.
Thank you very much, sir, for sharing your profound knowledge on healthcare systems in real-life scenarios and the current significant improvements on AI technologies. Thank you. A true leader has the confidence to stand alone, the courage to make tough decisions, and the compassion to listen to the needs of others. We have amongst us such an eminent personality, the president of this inaugural ceremony, Honorable Vice Chancellor of Mangalore University, Professor Jairaj Amin sir. I now request Professor Jairaj Amin sir to share his insights and deliver the presidential remarks.
Good morning, everybody. Esteemed guests, Professor H.S. Nagendra Swami, my colleague Dr. Professor B.H. Shekhar, Dr. Prakash, my other colleagues, Dr. A.M. Khan, Bharati Pilla, Dr. Sharmila Kumari, all other invitees, participants, my friends from the computer science, computer center, Vijay, Anand, Ajay, and all others who are present here. Now this gives me great pleasure to be here on this occasion. But I should actually start with an apology for being late to the program, because I know that I kept you waiting for more than 40 minutes or almost in 1 hour. In fact, as a more than a vice chancellor, as a teacher, I would say that none of the programs of this type should actually wait for anybody to start. It should start on time. Whether it's a politician, whether it's a vice chancellor, whoever it is, you should just start. Let the other people come and then later wait for your time, rather than you wait for them. Because this is a gathering of the experts, and you are all here actually to gain something by the talk of the experts. So why should actually others actually make you wait? But somehow, Professor Shekhar probably thought that this is a gathering of the experts, so better to listen to a non-expert. So, so therefore he has actually dragged an odd man here to this gathering. And as Bharati Pillar said, she wants to, to share my viewpoints, thoughts on these things. Now, what do I have, thoughts on this highly specialized area? I don't know, because I'm completely an alien to this branch, and I don't know what to speak. But as I understand, a very simple thing, and also, the chief guest has actually elaborately, spoken about the importance of machine learning and deep learning on the medical imaging purpose. But what I thought actually was, this is actually a branch which would eventually render the radiologist completely obsolete. Because, I think over a period of time, in the name of helping the radiologists, I don't know whether the radiologists are going to become unemployed. But this is because this is an area where the technology would completely take over the understanding of the nuances in the medical things. Because this area, is something that is going to help the analysts, I think the doctors in this case, to understand certain things very deeply. I am not able to actually get into the specifics, but what I understand is that, today, as the the chief guest had said, the health has actually become extremely important. We are all actually bothered about the guest. I don't think anybody today would say that I don't take care of the health. So we have become health conscious because we all know that every day we have health challenges coming up in different forms. So we, on one hand, we have become health conscious, and on the other hand, we also expect the medical science also to progress very fast, so that when in case we actually become affected with any of the problems, the health machinery would be there to take care of us. So in this kind of healthcare delivery, these kind of techniques, I'm sure that would actually help in the big way. Today we go to the hospital, we actually go for MRI scan, CT scan, and all kind of scans. But I understand that this deep learning would actually help to better understand the CT scans and other things, because it would actually help us to understand the minutest problems that probably is not visible to the human eyes in certain things. I might be wrong. Please actually you have to correct me because you are all expert. I'm just talking as an layperson on this kind of things. Now this is important because this deep learning would actually help us to understand our problems in a more accurate manner, and also to improve the efficiency in overcoming those challenges here. Because here, we are actually focusing on automated learning, which the human eyes cannot capture. And this is very important for understanding a very minute kind of things. For instance, this would actually become extremely important in the research and drug delivery, because here we actually understand how different drugs can affect the human body at the molecular level, because you have actually gone into the minutest part of the human cells and try to understand what is happening through these images here. So this would actually help us in the speeding of the diagnosis, and also very significantly it can also help us to evolve certain personalized diagnostic system, because each human body might be very different. Of course, in the allopathic system we don't say, but if you go to homeopathic or the Ayurvedic kind of a system, they would say that the people are same, but then the human body's composition is different. So here, by this kind of an imaging processing, we can actually understand the human body in an accurate manner, and then try to help them by coming out with the different types of drugs and other things. So this would actually help us in real time monitoring, and also actually speeding up the diagnosis, also helping us to come out with the personalized kind of medicines here. So I understand that therefore this is an evolving subject which probably has come into existence about 5-6 years back, if not more. And this has a great potentialities for the human health. So you are all here to actually gain additional knowledge. I know that you are all experts in your own way, in your area, but you are all here to actually add to that knowledge by attending this session. And I saw the list also, so you are actually being addressed by the best known brains in this area. So I'm sure that your next 1 week would be very fruitful. You would actually learn a lot of things, and this is a kind of course that is actually and as I see it from the list, it actually includes both theory and practice. So you will also be visiting certain hospitals. You will also be going around the city and trying to understand certain things in a practical manner. So I think this blend of theory and practice would actually help you to gain a lot of knowledge, which you would actually continue once you go back to your own institutions. So I wish you all a great success. I would also like to compliment Dr. Shekhar for bringing this novel kind of courses to our university and helping the the practitioners and the teachers through this FTP program. So I once again wish you all the best, and I also wish you all a very happy and pleasant stay in Mangalore University. So enjoy the nature. In fact, this is the best climate of the year in Mangalore. Some of you might actually feel that it's too cold or too hot, but this is actually the best part of the climate in Mangalore. So I hope all of you would actually enjoy your stay, benefit a great deal by the intellectual inputs that are given in this FTP program, and I will also go back with all the good memories of Mangalore. Wish you all the best once again. Thank you for the patience.
Thank you, sir, for the presidential remarks. I also would like to thank you, sir, for your gracious presence in spite of your hectic schedule. This shows your keen interest in academic programs as well as your support. Thank you. I now request Professor B.S. Shekhar, sir, the FDP coordinator, to present a memento to our Honorable Vice Chancellor, Professor Jairaj Amin, sir, as a token of gratitude. Thank you. Thank you is the best prayer that anyone could say. Thank you expresses extreme gratitude, humility and understanding. To put across our words of gratitude, I now request Mr. Prakash M., Assistant Professor, Department of Computer Science, Mangalore University. Over to you, sir.
Good morning, everyone. We have gathered here to inaugurate 6 days faculty development program on elevating healthcare through advanced deep learning innovations in medical image processing. So just like any other good things in life comes to an end, this inauguration function has come to an end. And I take this opportunity to propose vote of thanks on behalf of Department of Computer Science, Mangalore University. At the outset, I would like to thank our Honorable Vice Chancellor, Professor Jairaj Amin, sir, who is a president of this function. Thank you so much, sir, for your advice and support and cooperation. I feel extremely happy to thank our chief guest and keynote speaker, Professor H.S. Nagendra Swami, sir, for accepting our invitation and coming here to share his knowledge. Thank you very much, sir. I also extend my gratitude to the backbone of this event, the coordinator of this function, 6 days FDP, Dr. Professor Shekhar, sir. Thank you so much. I also would like to extend my sincere gratitude to the chairperson of this, our department, Professor Manjaya, sir, for his constant support and cooperation for all the events. A special thanks to Dr. A.M. Khan, sir, Dr. Bharati Pillar, madam, and Dr. Sharmila Kumari, ma'am, for their presence. And also I would like to extend my sincere gratitude to all the organizing committee members, teaching staff, non-teaching staff, research scholars as well as students who supported this event. Thank you. And also I would like to thank the technical team led by Dr. H.L. Sisireka madam for their constant support for live streaming this event on YouTube. Thank you so much. And also I would like to thank all the participants who have come from different places for this event. Thank you. And at last, I would like to thank AICT at all for sponsoring this program. So with this, with warm words, I would like to thank each one of you. Thank you.
Thank you, Mr. Prakash. We have come to an end of this inaugural ceremony. After a tea break, we will reconvene for the technical session. Let us actively participate in this program and contribute to the advancement of medical image processing. I wish you all the best and also have a great learning experience through this FTP program. We will have a group photo after this outside this hall. Thank you.
Okay. So, good afternoon to one and all. So, thank you, madam, for your introduction about me. Let me start the session because we are already late. I may continue till 1:30, and I try to present before you some of the very important and basic concepts and points which helps you to understand the subsequent concepts in the subsequent sessions. Let me start the session with a very meaningful quote. Keep going. Each step may get harder, but don't stop. The view is beautiful at the top. This just reminds us that there is no shortcut to success, only the hard work. Whether it's a research or any profession for that matter, only the hard work will yield better results, and then only we can think something beautiful in our life. And that's how, whenever we want to reach or whenever we want to get a very accurate results in the work, definitely it should be very, very precise. So definitely reaching that level is not so easy, and that's what the meaning. So with this, so the topic of this technical session is machine learning for medical image processing. I thought maybe this title is quite relevant to the points what I am going to discuss with you today. The person who has health as hope and who has hope as everything. This is said by it's an Arabian proverb. The groundwork for all happiness is good health. When health is absent, wisdom cannot reveal itself, art cannot manifest, strength cannot fight, wealth becomes useless, and intelligence cannot be applied. So because of this, we all have to maintain our physical and mental health so that we can achieve something in our life. Because from today till end of this week, we are all involved in various challenges and issues related to medical healthcare system, and definitely all this seems to be very meaningful to us. So the presentation outline covers a brief introduction to healthcare and machine learning and medical imaging modalities, the tools used for medical image analysis, the medical image analysis techniques, the key tasks involved in medical image processing, the applications of medical image processing in healthcare, and data sets used in the domain of healthcare, then statistics about medical image processing modalities, techniques, and tools used in medical image processing, and the few works related to medical image, machine learning and data learning techniques for medical image processing, a comprehensive review on a computer-aided breast cancer detection and classification in mammography, a very recent literature review, followed by summary and conclusion and few references. So I just thought of presenting this before you because it gives you a very solid and essential points and concepts to understand the advanced concepts of machine learning, particularly for medical image processing. So this is a kind of an overview of the entire FDP, okay, like a bird's eye view of the FDP program, wherein each of these points will be discussed in depth by the experts who will be handling the sessions in the subsequent days, in the subsequent sessions. Because as I saw the invitation and the schedule, FDP schedule, I understand that doctors will be presenting the core concepts of medical healthcare in some sessions. Industry experiments will be presenting in depth the deep learning architectures, machine learning architectures, and the mathematics behind machine learning and deep architectures. And also we have academicians who have got a rich experience in research. They are also going to explain you the basics and also the depth of these architectures. So today I just wanted to give you a bird's eye view of all these things in the next 1.5 hours as such. So to start with, what is healthcare technology? Of course, it's very much familiar to us, but still, for the sake of continuity and completeness, I just wanted to present before you what is in healthcare technology. Healthcare technology is any technology including medical devices, IT systems, algorithms, artificial intelligence, cloud and blockchain design to support healthcare organization. We have already witnessed all these things in our day-to-day life in one or the other way in any healthcare system, because we have a very intelligent imaging systems, and also we have of course medical devices, and also the IT algorithms and artificial intelligence based devising systems. So all these things are supporting the healthcare, and this what is the technology solutions we expect in future as well with high precision and accuracy. So this is what the healthcare technology components as such. So electronic healthcare records is one important area where a researcher can concentrate, because a lot of data will be generated every second, because almost all medical hospitals will be examining inpatients, outpatients, discharge summary, prescriptions, symptoms recording, everything. All those things are recorded in the form of a text, so large volume of text will be generated every second, and it's very difficult to manage that. Definitely a technological solution is very much required to manage, because definitely it's kind of a big data which is dynamic in nature, voluminous, and also unstructured, right? When a doctor writes a prescription and when a patient explains the symptoms, so all those things are unstructured, and we need to convert that unstructured into structured data, and that's where we need a support, a technological support, or a kind of algorithms which can extract the data and convert that into a structured form, where that structured data can be used further for analysis, so that some very meaningful and decisions can be taken at the right time. So that's how a lot of research work is also going in this direction, electronic health record systems. And next is the clinical decision support system. Definitely we are all aware of this. An X-ray will support the doctor to make a decision. Similarly, a CT scan reports or MRI reports. Okay, so without such devices, and it's very difficult for a doctor to make a decision. That's how clinical decision support systems also plays a very significant role in healthcare technology, where one can think of contributing your ideas in this direction. Analytics and data visualization tools. Similarly, care gap management systems, self-check-in kiosks, predictive analytics, appointment management systems, and digital therapists, mobile web apps, and etc. Even we have heard about the telemedicine. You can take an appointment online and you can interact with the doctor for a primary examination. And based on that, you can meet the doctor if required, maybe after having prescribed 2 or 3 days of treatment. Maybe you can take and then later you can meet the doctor physically. So that's how all these things are supporting in one or the other way for a healthcare technology. So with this, how technology has changed healthcare. Healthcare technology can streamline processes, automate tasks, and improve workflows at a scale that is not possible for humans alone. That's what I already mentioned, the process. It's very much important for us to understand the process. As I already mentioned, the P stands for proficiency. If any expert working in healthcare technology or a system is not very proficient, then definitely we can expect a wrong data. Okay? And similarly, if a doctor could not properly diagnose, maybe looking at the X-ray images or any other images as such, without the support of technology, then definitely the prediction will be something wrong. That's why many times we are advised to take the second opinion, third opinion whenever the decision is very critical. So that's how in all these cases, definitely the technology will support for early decision making, quick decision making, because a right decision at the right time is very much important to save the life and also the cost. So in this direction, it's very difficult for any humans to do it alone. We need a technology support at various levels. Okay, so that's how the technology has changed healthcare and a lot of things to still go ahead. So technology solutions are helping healthcare professionals to improve patient care, create better experiment and experiences, and also the reduce the burnout. For example, if at all you want to meet a doctor in a Bangalore, then definitely you have to spend the whole day, because we have visited some hospitals there in a Bangalore and some research association. And even we see the patients, you see in Nimans, the patients will go early in the morning 5:30. There will be a long queue, and just to take an appointment they have to spend minimum 2.5 hours. A long queue, right? And definitely they have to wait for more than 5 to 6 hours just to get 5 to 10 minutes of interaction with the doctor. Even the doctor will not tell anything, just examine, and again they will ask you to follow up. So that's how the cost, the time, the effort, and everything is really much when it comes to the manual way of getting things done. But however, that may be required, but still we can reduce unwanted visits and we can get suggestions by making use of the technology in online as well. And that's how we can create a better experiences and reduce the burnout. So here, the technology solutions for addressing public health emergencies and policy changes, as we already mentioned, data analytic tools. So we, the researchers and the technocrats from the industry, we can collaborate and we can come out with the data analytics tools which help the doctors to make predictions more accurately, well in advance, with a short period of time. So that's how the data analytic tools can be designed. Okay, so maybe some of you have seen this in the hospitals or in a clinics where the doctors look at the x-rays and they take a decision. But still, certain things are not very clear. Maybe is it possible for us to provide the tools where we can enhance and we can see, or we can scale it up and we can see. But that cannot be done by just using a physical, x-ray sheet. But if we use a technology-based solution for that, definitely you can zoom it up to any scale and you can see even the minute and region of interest on which a doctor can make a decision. So that's how a lot of data analytics tools can be designed by looking at the medical requirement, problems, and also the solution to that. That's where we researchers and industrialists can collaborate and we can come out with data analytics tools. And AI and ML tools, very recently these AI and ML tools have drawn a lot of attention by the researchers, where a lot of people are working in this direction, lot of companies have an association with many academic institutions and industries, where they just wanted to come out very intelligent algorithms which can make decisions, right, on their own. That's how they act as an expert systems, right? So there is a scope for us to think in this direction. And telehealth solutions and digital health solutions and interoperability solutions. So we can share the data with other experts in other hospitals. For example, we wanted to, share the data with an expert who's in USA or in Canada or in Australia. So definitely through the technology it is possible for us to associate with them, and we can definitely get their support, and we can work collaboratively so that we can provide the technology solutions to public health emergencies and policies, right? So you might have heard many such instances, maybe in the news or in, even you can see it in the web sources as well. So this is in summary or in a brief how technology can support the healthcare, okay, and what is our role and responsibilities as academicians and researchers. So coming to the machine learning particularly, because today we talk about the machine learning, because we want to make machines intelligent where it can learn. So definitely if we expect the machines to assist the doctors, then definitely the machine should also be intelligent machines. Otherwise we cannot consider their support. So this machine learning is a branch of artificial intelligence where machines learn from the data by identifying the patterns and automate the decision making with minimum human intervention. For example, if a pathologist looks at the blood samples and he can look at the images, and he may need to spend more than an hour to identify particular cells of interest and later draw a conclusion out of it. But suppose if we design a AI-enabled machine learning algorithms to do the task, then definitely it can do the task maybe in minutes or even in a fraction of seconds as well. Because if you test that algorithm with lot of samples, and if you confirm that the system works well, and if the doctors give their opinion that yes, the system can work well as the way the experts are predicting, then definitely we can deploy such a system, and that definitely, right, help the doctors, where we can save the money, where we can save the time, where we can save the effort. Okay, so that's how we are focusing on designing artificially intelligent algorithms, where we can embed those algorithms into the machine, and machine can think like an expert, and that's how help the doctors, right? So this is what is exactly a machine learning, the philosophy behind the machine learning. So what is medical imaging and how it is related with a machine learning? So a medical imaging is the technique and the process of creating visual representation of the interior of a body for a clinical analysis and medical intervention, as well as visual representation of the function of some organs or tissues. So definitely it's without such kind of technology, it is not possible for us to see the human anatomy. How can I see a person, or how can I see a doctor can see a patient's internal mechanism, right? The heartbeat, or a blood pressure, or a sugar level, or HDL, or any other BMI statistics, and etc. So definitely we need a kind of technology wherein we can capture the image information from the body, and also we can collect the other statistics like a blood pressure or hemoglobin, right, and weight, many things as such, sugar level and etc. So with all that, we'll be able to analyze the data, and then we can make a decision, and then we can prescribe the treatment to the patients if required. So in this context, the medical imaging basically focuses on analyzing the images, and through which some interesting patterns can be observed which are not possible most of the time for a doctor to see in a bare eye. Okay, so that's how this medical image processing will support in such situation are the cases where we can analyze and we can help the doctors to identify very precisely. I can just give one simple example to support this statement. So when we have visited one industry in Mysore, you might have heard about it, the Scanray, where they are now the upcoming industry in manufacturing medical equipments for various medical requirements. And they were telling that their machines will produce the X-ray images, and most of the time the X-ray images are not of good quality. The reason could be low dosage of X-rays, because we cannot allow the patients to subject it to the high dose of X-rays. It's harmful. Suppose if we give low dosage of X-ray, then definitely the X-ray images will not be of that quality. When doctors looks at those X-ray images, definitely some important information will be missing there, and it's very difficult for a doctor to make a decision, a precise decision. Then suppose if we apply a medical image techniques like image enhancement, you might have heard about it, image enhancement. A low intensity image can be enhanced, some important edges can be enhanced and can be sharpened, and unwanted information can be removed, the noise can be removed, and etc. And a region of interest can be extracted for subsequent analysis and all those things. So by doing so definitely we can come out with a good information, imaging information for the doctors to make a decision. So that's where in fact they wanted to collaborate with the researchers, right? And in fact 3 of our students went there an internship and they worked, and 1 student got observed there only, and right now they are working on X-ray image enhancement. Okay, they look at the possibilities of different imaging, X-ray imaging devices, and what kind of quality of images that are produced, and accordingly what sort of enhancement is required or analysis is required. So that's how the medical imaging, not only that X-ray, but in many other modalities, they plays a very important role, which we are going to understand with some more examples. And this is what, look at here. This is one of the brain images, sectional images. Similar, look at this one and this. So it is possible only through a medical imaging where the doctors can get that information and then analyze and subsequently make a decision. That's how medical imaging is very much important and plays a very significant role in a medical in a healthcare sector. So here is another example of how a doctor can study the heart beats or internal mechanism of heart. So normal heart with, this is what is the some sort of disease. Okay, you will see the abbreviation. Okay, so normal heart versus DCM, and you can see, but here the texts are not very clear. Dilated cardiomyopathy, DCM, dilated cardiomyopathy. This is the normal, and this is what is, right? Okay, so now you can see enlarged left ventricle, enlarged right ventricle, thinned wall, enlarged left atrium, etc. So now this is the normal and this is the abnormal, right? So these kind of images will help doctors to precisely localize the region of interest, and then they can study what is the severity of the disease and accordingly what level of treatment is required, and all these things cannot be done without the support of medical imaging. And similarly, another example like normal left ventricle and enlarged right ventricle. So further this information, look at here. So this region of interest can be segmented, can be enlarged, and can be studied further, and we can make a decision, right? So normal heart versus ARV, and similarly normal heart versus HCM, hypertherapeutic tropic and cardiomyopathy. Again, another kind of disease you can look at here. And similarly, normal heart with MINF. Okay, so another disease. So all these things are possible only through the medical imaging. And what is really required here is what sort of limitations are there in the current medical imaging technology. Because definitely there is a scope for the researchers and the technocrats to uplift the quality of these devices over a period of time, because the research always comes out with the new ideas which definitely enhance the quality. So that's where what we need to understand here is what are the limitations of the existing technology, how those limitations can be addressed. Okay, so that's where our role is very, very important. This is just only to give you an idea how medical imaging is very, very important. And another is diagnosis of lung for nodules and breast lesions. Okay, inter-observer variation, intra-observer variation, dependence on experience, human error. So all these are the part of the radiologist diagnosis. Inter-observer variation, right? For example, Dr. A observes the image and the same image has been observed by Dr. B. So what sort of differences we can see in the observations? Okay, so whether that difference is acceptable, because many times it happens that Dr. A suggests no need to go for an operation. Another doctor may suggest you need to go for an operation. Right. So why is that difference of opinion among the doctors or among the experts? What is the reason for such variations among the doctors? And even sometimes intra-observer variation. For example, if some images are given to the same doctor over a period of time, then what could be the variation in their observations for the same patient and for the same disease as such? Intra-observer variation. Dependence on experience. So definitely many times we say whether this doctor is highly qualified, whether he is returned from abroad or very good universities, whether he is trained and well and he has a good rich experience in the domain. So all those things matters. Because today you might have seen that when you look at the clinic and when you look at the doctor's qualification, if you see that just MBBS, then you just visit the doctor only for a small reasons like cough, cold and all. Right, but we always look for the highly proficient and experienced doctors when we are very much particular with a particular disease, like maybe high specialist, we call them as a high specialist, right, neurosurgeons, okay, etc. That's what the dependence on experience and also the human error, as we already mentioned. Even the hospitals and the doctors have accepted that there is a 30% of the error, right, when they are diagnosing any images or any data as such. But here, computer-aided diagnosis will try to overcome all these issues. Decision support, resolve intra-observer variation, avoid unnecessary biopsy. All these things are possible with the support of medical imaging, and that's how we can elevate the quality of healthcare systems. So here, why machine learning for medical imaging? Now we understand what is machine learning and why, what is medical image processing. Now the question is, why machine learning for medical image processing? So machine learning helps the physicians to interpret medical images using computer-aided design in a small period of time. This we already mentioned. And machine algorithms can be used for challenging tasks like segmentation with CT scan, breast cancer and mammography, segmenting brain tumors with MRI and etc., where a precise segmentation may not be possible in many cases by a doctor when done manually. Okay, so that's where this machine learning and intelligent algorithms will help us to do the task very precisely. And in this context, some of the research questions are, what are the various medical image modalities for classifying the diseases? So this is very much important for researchers, because unless we understand the various image modalities, we cannot go further, explore and define the problem for our research. So it's very much important to understand this, and subsequently we do a kind of literature on that and what has been done, right? What are the gaps and how can we fill up that gaps? So that's where understanding the various medical image modalities are very much important to further go with research in this direction. What are the tools and techniques used for medical imaging? This is also very much important, because you need to understand the techniques and the tools, because today you cannot do these high-end computations without support of tools, right? Because maybe 10-15 years back we were using C++ programming language or a MATLAB, where we used to do simple, propose simple algorithms for extracting features manually from for a object classification, right, or any such kind of things. But when it comes to medical image processing, such algorithms may be, no, in today's context may seems to be very obsolete. Okay, so we need to process a large volume of data and also with a high precision. Then definitely the recent tools need to be used. So we should have a knowledge about the recent tools. So what are the tools and the techniques used for medical imaging, and understanding about this is also very much important. And what are the various data sets used by several researchers in the domain of healthcare? This is also very much important, because many a times getting the data for a medical image analysis is not so easy, because there are a lot of issues with the hospitals, right? And there is a confidentiality. You cannot get a medical data easily, right? Unless you have a collaboration with the hospitals and the doctors and with a proper permission, we are not supposed to use any data for any analysis. And also, sometimes we get the data which is approved by Indian Medical Council of Research, where we can use it. But sometimes you may have to prepare your own data sets going to various hospitals, because some data sets are not available freely, right? And even many times you cannot just say that working on one very predefined data set and you can say you will get a 99% of accuracy, but when you deploy such a system in reality, it may not produce you 99% accuracy, right? So definitely working on a real data set is very, very important in a medical sector. So what are the various data sets used by several researchers in the domain to start your research work, and later you can add more and more challenging data sets, and you can study the performance of your algorithm, you can fine tune it. Okay, so that's how our research should proceed in this direction. And what are the present techniques of ML and DL used for medical imaging? This is a kind of survey, right? Maybe if at all you want to work on CT scan images, or you want to work on MRI images data set or mammography. So what are the current state of the art work that has already been done by the researchers across the globe, where they have applied machine learning techniques and deep learning techniques, on what data sets they have worked, what results they have claimed. Okay, so that information will definitely help us to define our research goals and identify the gaps, and accordingly we can propose a new ideas. Okay, so that's how it's very much important to understand this present techniques of ML and DL used for medical imaging. And also, when you are studying this, it's also very much important for us to observe what are the considered parameters while selecting the classifiers. Okay, right? So we will see some examples there. What are the parameters? So maybe it's an accuracy, specificity, sensitivity, right? Okay, F measure, right? So precision, recall. So all those things are the parameters need to be considered while selecting a classifier and evaluating the performance of an algorithm. So that need to be understood. And also, what are the evaluation metrics used to evaluate the classification models? Okay, so of course, some of the parameters can be used for classifiers and also to evaluate a particular classification model as well. So, and another important thing is, what are the results of comparative analysis of machine learning classifiers and deep learning models based on experiments using a mammogram images? So I have got one very interesting and recent survey information. I just wanted to present before you that comparative analysis of ML classifiers and DL models based on experiments using mammogramic images. Because to apply a deep learning models, as we already understand, of course, some of you have already done some kind of research on this, and some of you are about to start, and some of you might have already started research in this direction. If so, then definitely you have understood that DL models outperforms the machine learning models because of their complexity and also their learning ability and non-linearity. But what is very much important is the huge amount of data. But finding out the huge amount of data for a medical applications is not so easy, it's very challenging. So if you don't have that large data, then definitely the performance of the DL models are much more lesser than the machine learning classifiers. For example, if you see the Google images and Google face recognition applications, billions of images have been trained. Billions of images, not just millions, billions of images have been trained, and because of that, such a complex network will be able to identify you whenever you are posed in any occasions as such. If you say Google Photos, it will get you, right, where and all you have appeared and in which photos you are, it can recognize your, detect your face and recognize who you are and all those things, but it demands a lot of training data and also a complex system, and also a high-end computing is very much required to deploy a DL models. Okay, so sometimes it is not possible, right? Sometimes it is not possible. Then definitely how machine learning classifiers supports in such cases, right? So such understanding is also very much important. And with this, okay. So now let's look at the medical imaging modalities. Okay, so of course the next few slides are just a brief information regarding medical imaging modalities. I don't think we need any discussion on that, but just for your kind of information, I just wanted to give you these details. HiScan2, I don't know how many of you have heard about this HiScan2 modality. So this is a dual iris capture scanner, right? It captures both the eyes information and it produces iris images that are compliant with an ANSI. This is what is the standard by a medical council, right? These are the standards. So it can produce the images to that, with that standard, where the doctors can analyze that image and they can look at some of the ailments related to the ophthalmology. That is high, right? So this is one modality. So if at all we want to work in this direction, definitely we need to know more about this HiScan2 standards and how images are produced and how we can work on such images. So a domain knowledge is very much required to understand this thing. Another is the CT scan. All of you are quite aware of this, right? It's a very popular terminology. We have heard about it. CT scan, a computerized tomography, right? So scan combines a series of X-ray images taken from a different angles around the human body, and this also used to study internal anatomy of the human, to study some diseases and the ailments. And this is the MRI scan. It uses a strong magnetic fields and magnetic field gradients and radio waves to generate images of the organs in the body. MRI scan. This is also a very popular word we have heard, MRI scanning. I will show you what are the images produced in each modalities and for what reasons doctors are using those modalities, okay, for what diseases and all, right? So another is very common is the mammogram. This is also very much familiar to all of us. It's an X-ray examination of the breast and is used to detect and diagnose breast disease in a woman. A lot of work has been done in this direction because quite frequently, right? So more women are subject, are very much susceptible to these kind of breast disease. So early detection will definitely save the life and it is curable, right? So that's how the mammogram plays a very significant role in medical healthcare. Okay. So then this is ECG, electrocardiogram, record the electrical signal from the heart to check for different heart conditions. This is also quite familiar to us. And electroencephalogram, EEG, record the electrical activity in a brain using small metal disc electrodes attached to the skull. Okay. So now look at these modalities and the images what they produce. Okay. HiScan2, this what is the image. Okay, this is the captured iris image. Okay, so with this the doctors can analyze and even your AI enabled algorithms can study this with the, that's how the domain knowledge is very much important. So whenever we are working on any medical applications, definitely the doctors support is very much required, because even if at all we want to design an algorithm, we need to understand how doctors examine and what information they are trying to capture. So interacting with an expert doctor will definitely helps you to get a lot of input where those details will be incorporated into the algorithm, and then we can fine tune it with the advice of the doctors, and then we can come out with an automated system for that. So this what is the captured iris image. This is the MRI scanner, right? And this is the MRI scanned image. Okay. So, and similarly, we have CT scanner and CT scan image, mammogram scanner and mammogram image, mammography. And then we have ECG machine and ECG image, EEG machine and EEG, right? You can see here some of the different signals here, okay? So, awareness, alertness, relaxed, tired, sleep, and such. The signals vary depending upon the mood of the person, okay? So, that's how we can study all those things, because even today, just a lot of people are getting to depression, right? Now it is a very common because of lifestyle and maybe because of many stress as such, okay? So now the psychiatry, the doctor or an expert can observe the behavior of a person, interact with them, and they try to estimate what is the depression level of a patient, okay? So even just 2 days back, one of the students came to me and he said that he cannot concentrate on studies, right? Even though he has time, he cannot concentrate, and some unnecessary things will be going on, and that leads to depression, and it will not allow him to study, right? Then I asked him, any problems at home or any problems in the department or anything as such? He says nothing as such, right? Well-doing family, a very good environment, very good friend, but still I don't know why he is depressed. It's a very challenging thing, right? So definitely, according to some survey, every day not less than 10 to 15 students will be visiting a psychiatry expert just to take a counseling. Now the question is it possible for us to support a doctor or a psychiatry expert through AI-enabled systems, right? So by observing the behavior or by understanding the voice information, facial expressions and writing, because most of the times the depressed people will always speak in a negative way, right? And also they write or express their views in a negative way. So by understanding their behavior and their thoughts, so it is possible for us to characterize, and then we can come out with an automated system, right, which supports the doctors to quickly come to a conclusion or assessing the people and all. So that's how all these modalities and all these kinds of images which are generated through these modalities will help the doctors, okay? So, but what we need to do is, we have to support the doctors with the technology, okay? So, with this, now, another very important thing is the ultrasound scan. You have already heard it. Also called as a sonogram, is a procedure that uses a high frequency sound waves to create an image of part of the body inside the body. Ultrasound scan can be used to monitor and an unborn baby, diagnose a condition or guide a surgeon during certain procedure, right? Ultrasound scanner, I think many of you have already heard about it. Because after 3 or 4 months, now the technology has been advanced to such an extent that where once in 3 months or sometimes in some serious cases every week or 15 days, right, a pregnant woman has to visit the scanning centers and they have to be monitored. Otherwise the consequences will be very, very difficult, okay? So I can just, because I was closely familiar with this activity, because in my personal, I have my personal experience. My first child is a premature baby, right, around 8 months, and due to some issues, right, placental resistance. The doctors were telling that even they could not identify why that placental resistance happens. If they are able to identify the cause for that, definitely they will get a very good award, right, in a medical sector. The placental resistance, right, they identified that in the 7th month, and they tried to somehow address that particular problem, right. Almost for 1 month they could not do anything. It continues, the same state continues, and then the doctor suggested, no, there is no way, because the food is not supplied to the kid, baby inside the mother womb, right? So there is no option, we have to do surgery, cesarean, and then we have to treat the baby outside only. So definitely the incubation and all is the common thing what we have seen. So at that time, once in 3 months in a normal way, or in case if there are any serious issues, maybe once in, because I used to take my wife every 15 days for almost 1.5 months, right? And they used to regularly monitor every week. So the same ultrasound, they used to see how baby behaves inside, whether the heartbeat is correct, whether the baby activities are normal, everything they used to study, right? So that's how this ultrasound scanner also is, now it's very common, okay? And now advanced ultrasound systems are used to even better understand the movements of the baby inside the mother womb, wherein they can suggest the possible precautions, right? And I will tell you the another thing, the first baby was like that, even the second, my son, right, maybe in the 6th month, again the doctors suggested, that examined that something wrong. I was very much depressed at the time, and I visited many doctors in Mysore, experts, all are expert doctors, right? And they suggested they have to take the complete rest. And of course, she took complete rest, but in spite of that, she has to visit the scanning center once in a week. Every week we used to go to one scanning center. Of course, he is trained in UK, Navya Diagnostic Center, I still remember. So almost now my son is 10-year-old. So in the 6th month, doctor has suggested that there is no way we have to discard. That was the final decision given by the doctor. He said that no way, you have to discard. I am not giving you any guarantee whether the baby will born healthy. Then you have to face the complete consequences till the baby is alive. Because one of my close relatives, doctor, he is a doctor, and his son is right now 24 years old boy, right? He is completely, disorder. From the past 20 years, they are suffering like anything. That is what is the complications in the medical sector. So then they advised, right, at the time I somehow had a strong belief, right, I don't know, maybe God has blessed me, I decided let me see whatever happens. I took a strong decisions, but I took the advice from the doctors, I took a strong decision, I used to go to the clinic once in a week. So almost, because the baby at the time was just 1 kilogram. 1 kilogram in the month of, 6th month, 1 kilogram. So normally at the time of delivery, the baby weight will be more than 3 kilograms, normal, okay. So then they advised the rest, and they advised some other treatments and all. Every week we used to go there, we used to see the curve. I used to see how these things are done, okay, how the improvement, everything he was showing. So the next almost 3 months, 6 to 9 months, continuously monitoring this as per the advice. So finally, in the 9th month, the baby was almost 2.6 kilogram, and was healthy. He was showing me how the baby was active inside the womb. So through this ultrascan, colored Doppler, you might have heard about the colored Doppler, right? With that, successfully delivered, and now he is fantastic. So with all, and he is highly intelligent and technically is very strong. Okay, but why I am telling this experience is, without such support from medical sector, it would be very difficult, right? That's how even advanced technologies will definitely help us to save the life, and where we can give treatments well in advance. So this is what an example. So another is the fundus photography, and some of you might have heard about it, and some research is also going on in this direction, where the fundus images are captured by a special camera, fundus image scanner, and where the eye-related issues can be identified, right, glaucoma and other things, and where early treatment can be given to the patients. So this is what is called the fundus photography. This is another modality which can be used in a medical healthcare sector. So with this understanding about the various modalities, okay, now look at here, the doctors who rely on medical imaging. So because just now we understand what are the different modalities and how these modalities help doctors to treat the patients, and what is the purpose of a particular modality. Now look at here, orthopedic surgeons. The orthopedic surgeons use X-ray to assess bone breaks and spinal problems. And also they use MRI and CT scan to assess for sprain and strains. Look at, doctor is orthopedic surgeon. But they use X-ray for this bone breaks and spinal problems. But the same doctor also use MRI and CT scan to assess the sprains and strains in the muscle. Okay, that's how we can understand the modalities and how it helps the doctors. And the next is the neurologist, where the neurologist use the CT scan to view and assess the injuries, and MRI assess all brain structures, then fMRI assess the brain function and response, and PET view the metabolic activity in the brain, and cranial ultrasound used on the newborns and infants. Look at here, all these modalities are used by the neurologist for various reasons and for various analysis, right? So this how we can understand the modalities and how it helps the doctors. And subsequently, if at all we want to work on any of these images, keeping this as our major concern. For example, you want to work on the problems associated with neurology, and where you want to study these kind of images, then definitely you want to formulate your research problem around these modalities and keeping your major objective on neurology, right? That's how you need to define your research, and you can work in that direction by identifying the gaps. Another is the oncologist, where oncologists also use X-ray to detect the cancer in a bone and organs. And similarly, MRI detect cancer in a soft tissues and aid in staging. CT scan differentiate masses and assess tumors, and mammogram detect breast cancer. Ultrasound differentiate masses and guide biopsy. So these are the various modalities associated with oncologist, okay, the doctors. And the next is the cardiologist. They also use X-ray, assess the size and position of the heart, and echocardiogram visualize the blood flow through the heart. CT scan evaluate blood flow and cardiac tissues. MRI assess structures and around the heartbeat. So that's why many a times the doctors are suggesting to go for all these kind of scanning. Many times we see why we need to go for ECG, CT scan, X-ray, and sometimes they say, okay, go for X-ray, they cannot understand something, or they cannot come to the conclusion, then they suggest you to go for CT scan, and again they will suggest you to go for MRI scan. So this is how many a times the patient is subjected to different types of scanning, right? So this what is the reason from a technology point of view. And another is gynecologist, obstetrician and gynecologist. So they use 2D ultrasound, verify pregnancy and assess fetal development. Okay, 3D ultrasound, detailed assessment of fetus. Okay, now suppose if particular organs are not well developed, so maybe then the doctors advise to discard, maybe within 2 months or 3 months. Okay, so that's how they can say detailed assessment of fetus. And fetal echocardiogram assess the fetal heart, and MRI used to verify abnormalities with mother or baby, right? So this is what MRI. So this is how, for this particular specialist, these modalities help him to come to analyze and come to the conclusion in this way, right? So this is how the doctors use different modalities. So with this, now some of the tools used for medical image analysis, and I think many of you may be aware of all these things, because you might have already started working on these things for other requirements. The TensorFlow, it's a platform independent tool which takes an input from a multi-dimensional array called tensor and display the flow of instructions using a flowchart. And the Google Brain team created TensorFlow to enhance ML and DL research. Now, if at all you want to carry out your research and implement any algorithms using Python and all, and related to DL or ML, then definitely you have to use a tensor or a PyChart, PyTorch, and other kind of tools. Another is numerical Python, NumPy. It is the observation for numerical Python abbreviation. It's a library for the Python programming language, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. Okay, so that's what is numerical Python. And another is the MATLAB, quite familiar to all of us. It's a multi-paradigm programming language and numeric computing environment developed by MathWorks. It allows matrix manipulations and plotting of functions and data, implementation of algorithms, creation of user interfaces, and interfacing with programs written in other languages, right? So again, we can think of using a MATLAB for a early prototype analysis, and later we can come out with a complete working model with any other platform as such. And another is the R Studio. It is an integrated development environment for R programming language for statistical computing and graphics, because many times when we have electronics health record, a lot of statistical analysis need to be studied, maybe a kind of correlation, okay, and relationship between the various data modalities and all. So such analysis and statistics can be obtained and can also be visualized in a very beautiful way through different types of graphs with the support of R Studio. So these are some of the most popular tools which are being right now used for medical image analysis, right? Even you can try other variants of these tools as well, but the more popular are these tools, and some of them are open sources. You can easily download and you can use it, and some of them needs a license. Okay, so depending upon our requirement, and we can make use of these tools for our research. And with this, some of the techniques used for medical image analysis. Okay, right. So now I would like to give you some more technical details regarding the medical image processing. Of course, I hope that the other experts who deliver a lecture on various other topics related to this will give you more insight into this and working model, the mathematics behind that, all those things. But here, I just wanted to give you an overview, okay, a glimpse of this technique where it gives you the curiosity to understand much more in this direction. So one such popular technique is artificial neural network. If at all you want to understand any deep learning models or any convolutional neural network models, basic understanding about how artificial neural network works plays a very important role. And most of the times, we the researchers, we use the built-in Python libraries, and we call the library functions with the parameters, and we don't know what is happening inside. It looks like a black box, right? Unless we understand how the system works inside, it's not possible for us to fine-tune the algorithm. What we can do is, we can record the results. We can give the input data, we can record the results, and we can show it. But in case if at all we want to improve the results, and if at all we want to know why for this particular input data the system has failed, then such fine-tuning cannot be done unless we understand the internal mechanism of the system. Okay? And another very important thing we need to understand at this point of time is just one model or algorithm cannot solve all the problems. You cannot come out with a generalized model which works for all the problems with same precision or accuracy. So each and every analysis demands its own architecture, right? So definitely there is a scope for us to come out with a different architecture. So some of you who are already familiar with the deep learning models, you can see many architectures, right? For example, unit architecture is there, right? And similarly, VGG16 architecture is there, right? Euro architecture is there. A lot of architectures are there. Different variations are there. Why those architectures have been proposed by the researchers? The reason is very simple. Depending upon the requirement, you can fine-tune the architecture, and accordingly you can use it for a better results. So that's why, if at all we want to know the internal mechanism, then definitely a basic understanding and the philosophy behind that is very much important. The mathematics behind that is also very much important. Okay, so in that context, I just wanted to present before you some of the techniques, the basic ideas. So this is artificial neural network, or a special type of machine learning algorithms that are modeled after the human brain, how our human brain thinks, because we have billions of neurons in our brain. When I look at you, the first moment I can, when somebody introduces professor or any student as such, immediately my brain understand, remembers the name, remember the face, remember the voice, and remembers your behavior, right, and remembers your gait. Okay, many such kind of very complex information can be remembered, and it's all because of the billions of neurons which are inbuilt. And now look at the complexity of a human system, right? So if we explore our human system, I think it is much more complex than whatever the complex system we are designing here. Okay, and even it's not possible to match the natural intelligence what we possess, right? Still there are some limitations with the artificial intelligence algorithms, right? We have a generalization ability, but the system will not have such a generalization ability. Everything depends on the training. Okay, so now the scope is it possible for us to come out with a technology, an architecture which can almost mimic like a human being, right? Hope in future we can come out with such a technology, right? But right now, no way, we cannot meet the natural intelligence of a person. And the reason is, our brain is equipped with the billions of neurons, where each neuron is responsible for computing each piece of information, right? So, but such an ability, if at all we want to give it to the artificial intelligence machine, lot of theories, lot of techniques, and it becomes a very complex system where it demands high-end GPU, right? Not CPU. We have to use GPU. Then think of our brain, right? How many terabytes of information it can reserve, and how it can think, and what is the computational power, everything. So really it's an amazing, right? Understanding our human system itself is very amazing, right? So, and of course, this entire artificial neural network, convolutional neural network, deep learning models are all is actually inspired by a human brain, our neurons, okay? So, to understand that, the basic thing is, here are the inputs. X1 to Xn are the inputs given, and this is the first input layer. Then this is what is the hidden layer, and of course you can have as many hidden layers as you require to establish the non-linearity between the input and the output data. And next is the output layer, then Y1, Y2, Y3 and etc. Yn. Now just to understand how this entire system works, I just wanted to give you a simple example. I want to recognize a handwritten characters. Now look at the challenging thing. Most of the times we find it difficult to understand the doctor's handwriting, right? It's really a challenging task, right? Given the doctor's prescription, right? So let's look at how can, because only the medical shop persons, because they are very well trained, just by observing few letters they will be able to understand what is this medicine and all. But for a common people it's very difficult to understand what they have written. Now can we think of scanning that prescription slip and automatically convert that into a normal text in a Times New Roman or Arial where we can easily understand, right? So that's not that easy. But we can understand handwritten characters to a certain extent, but still it's a very challenging task for a machines. Now, if that is the case, then X1, X2, etc., Xn are the inputs. How we extract the features from each and every character, how we write A, how we write B, how we write C, how we write Z, right? It is not that how I write A, but I should also understand how A is written by this professor, somebody else, right? Because each one of you have your own writing style, and each one of you will write A, and we all can understand. That is what is the generalization ability we have. But how can we provide such a generalization ability to a machine? That is very challenging. So that's how we extract some features and we give it to the layers, and finally we just classify whether the given input symbol is A, whether the given input symbol is B, whether it is C or D. There are 26 classes in case of a English alphabets. If at all I want to design an artificial neural network to recognize the Kannada numerals and Kannada alphabets, then obviously I have to go for more than 52. So depending upon that, I need to define the output layer, and depending upon the number of features, I need to define the number of nodes in the input layer, and in between there are hidden layers. You can have as many hidden layers as you require, and depending upon the complexity of the problems you are going to solve, and that is the input response, and this is the error signal. Because when you are training a system, the system may wrongly understood. For example, if you have written A, and the system may wrongly understood that as a Q, right? You have written E, the system may wrongly understood that as a C, because such there are when we are writing handwritten symbols, then definitely there are some confusions as such. I and L, N and M when we write it. So We have to train the system. Definitely first time the system when trained may have an error. I just give input A, but the system says it is something else, like 9 or Q or something like that. So then such error will be distributed back, and that's what the error signal, right? It distributed back, and again these are the weights Wij. So because each and every neuron is connected and the weights are distributed accordingly, and again that data refined weights and input data is given to the each and every neuron, and again it does, and we call it epoch, right? So there it may take sometimes 100 epochs or 500 epochs, and there are a lot of mathematics behind that. How you can calculate the error, how you can distribute the errors, right? So all those things are the mathematical stuff needed to implement the artificial neural network, and once it has been implemented, then it acts as an expert system where you give the input and it can classify, right? So you can design artificial neural network for any simple task, a simple artificial neural network, and that is the model. So hopefully one of the experts who explains more about this will give you the internal mechanism and what is the mathematics involved in it. Okay, so error distribution functions and other things. Okay, back propagation algorithm. So all those things will be explained. So this is just only gist of artificial intelligence, okay, model. And another is the convolutional neural network model, right? A convolutional neural network is a category of machine learning model, namely a type of deep learning algorithm well suited for analyzing the visual data. This convolutional neural network uses principles from linear algebra, particularly convolution operations, to extract the features and identify the patterns within the images. Now this is what is a little complex architecture, unlike the previous architecture, where in the previous architectures we have just understood only this portion, but here we need to understand this also. Okay, because up to this earlier in an artificial neural network, it was manually extracted features, x1, x2, x3, etc. xn are manually extracted and they are given as input to this layer, and subsequent layer will process and finally it will classify the data. But now we have understand that, okay, extracting features manually is again a tedious task, not that precise. So we wanted to go for automatic extraction of the features. Now look at here how our brain works. Okay, now each and every person's faces, almost the features are same. The nose, ears, right, eyes, mouth, mustache, everything is, but still there is a difference, right? If I go with only the statistical features like that, I may not be able to classify the human beings, right? But still, I will be able to understand, maybe texture information is there, color information is there, and other information is there. Even sometimes the texture is also same, the color is also same, but still I can differentiate two people. So how is that ability is inbuilt into my brain? What features the system has extracted? Still we are not aware of it, right? In that, and that is the motivation actually given to the researchers, where they thought of this idea, and that is what is the convolution operation. So this is the given image, they define the kernel depending upon the type of the image, right? And a lot of parameters need to be studied as far as the kernel is concerned, and then it does the convolution. Okay, so again the person or an expert who is going to explain about the deep learning model, he will be explaining what exactly is the convolution operation, how convolution operation happens, the pooling, convolution, pooling, and etc. Right? So here, in a very simple way to understand this, so I need to define a kernel of size, say 3 cross 3 or 4 cross 4. I just run that kernel across the image and I extract some important information, and then that's what is called the convolution, right? And after that I need to desample, reduce the size of the image, okay? That's downsampling. So while doing downsampling, I need to do the pooling, so like max pooling or average pooling, right? Some of you may be aware of that. Okay, otherwise you can understand what I say. It's a simple thing, max pooling and average pooling. So given a 3 cross 3 portion of the image, you have an intensity information there, and out of that you can take the average intensity or you can take the maximum intensity and you can downsample that. That's what is called the pooling. And again you can apply the convolution operation on this, and again you will get another set of feature maps, and again pooling, and finally you will extract the features, and that features are given to the neural network, and that is capable of classifying the input data. So like whether it's a dog, whether it's a cat, whether it is a bird or lion, etc., right, or a human beings and etc. And this is what is called the feature map, and this complete steps, right, from here to here is called as a feature extraction. So automatically extracted by the system itself, the feature extraction, and then it does the classification, and the classification is done based on the probabilistic distribution, right? So this is how a convolutional neural network works. But a lot of mathematics behind that, because there, in order to do this one, you need to understand what is the step function, what is the loss function, and what are the kernels, what is the distribution. So a lot of mathematics are needed. That's how we need to understand the linear algebra, right? If you are able to understand, if you have studied this linear algebra and related subjects, then these things can be easily understood. Okay, because whenever we are defining any such kind of convolutional neural network architecture using any tools like Python or NumPy or TensorFlow, you need to define all these parameters. Okay, so a knowledge about this will definitely help you to fine-tune the algorithm better, and also you can propose some changes so that you can get a better accuracy with the result. So this what is the basic architecture. Madam, what to do? Shall we stop and continue in the afternoon? Okay, so because of time constraints, anyhow, we are going to meet in the afternoon session. I try to cover some other very interesting points and also some survey as such. Okay, so thank you. Bye now, and we shall meet again. Thank you.
I thank Dear participants, I thank Professor H.S. Nagendra Swami sir for an informative session emphasizing on significance of medical image processing, availability of intelligent tools for the medical image analysis, advances in the techniques designed to address the current challenges in the field, touching upon convolutional neural networks, highlighting its pivotal role in MIP. We have, thank you sir, we have now, we have one more session in the afternoon by sir. So now we will have a lunch break of 45 minutes. We will assemble back at 2:15. Okay, afternoon you will be having a technical session by Professor Nagendra Swami sir, and after that we will have a team formation for the participant presentation. Okay, thank you.
Check, 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 check.
Okay. Good afternoon, everyone. Welcome back to the post-lunch session. So, let's continue our discussion on the topic machine learning for medical image processing, which we discussed a few important points in the first session. So I understand that after the lunch it's very difficult to be alert. I try my level best to keep you active even in this session as well. Of course, there is nothing as such to go into the depth and scratch your head to understand the mathematics as far as these points are concerned. But of course, you have some such brainstorming sessions in the coming days, it seems, because the doctors will come with technocrats where they try to explain from the scratch each and every important points related to imaging technology and how doctors are assessing it, how technologies have understood, technocrats have understood that, how algorithm is behaving for different types of input data. So to that level, maybe the other experts go into the depth and they try to explain you, and that is what is very much required for a researcher rather than just studying it. Okay, so but here our objective is to introduce all these ideas to you, but I don't know how many of you have already started your research in this particular domain, because I heard that some of you have already registered for your research in this particular field, and some of you have completed your coursework also, and some of you have already started implementing some of the algorithms. Okay, so keeping all these things in mind, I try to give you some important observations in the literature, and also some important attempts done by the other researchers, and all these details are very much important for us to fine-tune our research so that we can do good work and very fruitful to the medical image sector. So now the idea what I would like to present right now is the transfer learning. And many of you might have already heard the definition of transfer learning, and of course it is our natural intelligence. We have already inbuilt that natural intelligence in us. Because when you teach the kid, okay, how to identify the alphabets in English or digits in English, maybe I don't think you need that much of effort to teach the same kid the alphabets in other language, right? So your learning will be faster. So similarly, suppose if I have designed an algorithm, artificial intelligence algorithm to grade the apple fruit, maybe that algorithm with little training can be easily adapted for grading other fruits and vegetables. So that knowledge is already there in every human being. So we need to put a lot of effort in understanding one domain. And once we understand that, that knowledge can be used in understanding another domain, okay, with little efforts, right? So that is what is the idea, which is already there within us. But we try to incorporate that idea and the concept into a machine learning algorithm or a machine learning model, and that's what is called a transfer learning. So it introduces a concept of transferring selected features from a predefined model to another model for solving the problem. It selects the feature or learns from the previous model and applies the features or learning to the new model to address different issues. Here symbolically we have just mentioned one example, like the model has been tried for this some task or a domain, as I already mentioned, maybe grading apples. So whatever the knowledge that is acquired during this training by the model or an algorithm can be used to grade other fruits, maybe a guava fruits or any other vegetables as such. So that's what the task domain. So storing knowledge and gain solving one problem and applying it to a different related problem is referred to as a transfer learning. And when you look at the literature, many people have explored this idea and they are successful in coming out some algorithms for the problems what they are trying to solve. For example, you can use one deep learning architecture, for example mobile net, and where the mobile net has already been trained for some traffic signal data or something like that, and you can use those weights, and again you can train that with some other related task, maybe related to automated driving system itself. Okay, so that's how this also a useful idea which you can explore as a part of your research. But how the pre-trained model features are used, and further parameter settings and all need to be studied, experimentally evaluated on the data set what you're using. Okay, so that's how definitely you can put an effort, and you can make an attempt in this direction as well. That's what is called a transfer learning. Another idea which has been explored by the researchers is the random forest. Again, you might have heard about the random forest technique in classifying the data. So the random forests or random decision forest is an ensemble learning method for classification, regression and other tasks that operates by constructing a multitude of decision trees at a training time. For a classification task, the output of random forest is the class selected by most trees. So you can understand the basic idea of a random forest with this simple diagram visualization. So this is the result one by one of the decision trees, and this is the result obtained by another decision tree. And similarly, what we do is we consider the majority voting. Okay, for example, if decision tree classifies the new sample as an apple, and this decision tree classifies the new sample as a pomegranate, and this decision tree classifies the new sample as an apple, then out of 3 decision trees, 2 have voted that the given sample is an apple, then we declare that sample as an apple. So that's how the random forest is an idea where we ensemble the decision by many decision trees, and finally either by voting or by averaging we are going to predict or we are going to classify. So this idea has also been explored by many researchers. Okay, so you can also try in a novel way how these random trees or decision trees are trained, and how this idea will be explored for a better result. So this is an idea of ensemble of classification, ensemble learning method for classification and etc. So another very popular technique explored by the researchers is the support vector machine. So this is a supervised max margin model with associated learning algorithm analyze data for classification and regression analysis. And whenever we have a data sample distribution, of course, which is a linear, but still there is overlapping. Okay, so if you don't follow this idea or the concept, then definitely for some samples which are at the margin, then the misclassification rate will be high. Okay, so in order to overcome that misclassification or to improve the classification accuracy of the model, what we try to do is we are trying to find out the best decision boundary which separates these two classes where the margin will be high. Okay, so we can find out different such hyperplanes, but we are very much interested in the hyperplane which has a maximum distance between the two classes. And by identifying such an hyperplane, by drawing a decision boundary in an optimized way, we will be able to minimize the misclassification, and that's how accuracy of a classifier can be improved. And this has already been studied and proved by many researchers, and for many problems the SVM has been very successfully explored. So you can even find the mathematical stuff behind the support vector machines, and you can understand how this algorithm is implemented. Okay, so many times what happens now, we will be having a packages. If we just call SVM with some parameters, it will produce the results, but we will not be able to understand the internal principle or the mechanism of a support vector machine. So if we are able to understand the internal working model, then we will be able to make some suggestions, or we can incorporate some changes, and that's how we can contribute something to the concept which is already proposed by somebody else. So marginal contribution. So that's also an incremental improvement to the research, and that is the contribution even we can give in our research. Okay, so this what is the support vector machine. So with this, as we just discussed, artificial neural networks, convolutional neural networks, and also support vector machine, transfer learning, and also random forest. So there are many such techniques that are explored by the researchers. You can just look at the literature survey and you can identify what is the accuracy or the results they have claimed on a particular data set. And accordingly, you can think of making use of that idea, or even you can fine tune that idea or a technique, and you can be more successful for your problem or for solving your problem. So with this observation or the note, now I just wanted to brief about some of the key tasks involved in medical image processing. So the first task is called the image acquisition. We already mentioned various imaging modalities. Okay, so ultrasound machine, MRI, CT scan, X-ray images. So the first thing is the image acquisition. So if you are working on some diseases related to brain or any other organ, then you need to understand the importance of this modality and the images which are captured from this modality, and that will be your data set. And similarly, the CT scan, X-ray. So we need to understand what is our problem domain or problem statement of your research, and accordingly we need to understand the image acquisition process, and that is the first step in our research. And sometimes, as we already mentioned, some standard data sets is available and you can work on the data set, but many times you may have to prepare a data set for your research problem, and that time you need to understand the image acquisition process and how to capture the images which are more suitable for you to process in the subsequent stages. Now, after image acquisition, we need to do image pre-processing. Okay, so it means cleaning up the image by removing noise, correcting artifacts, and enhancing the contrast. So when you look at the literature, in most of the works, there is a step called a pre-processing, and this is very much important because when you capture an image by using any of the modalities, there is a chance that the image has been captured with a noise. But sometimes noise may reduce the overall accuracy of the algorithm what you have implemented or what you have proposed. So the quality of image also plays a significant role in enhancing the performance of any model. So it's very much important that we need to concentrate on this, okay, in case if the images which have been captured during your image acquisition process contains some type of noise, maybe a salt and pepper noise or a Gaussian noise or any other types of noise. You need to use this pre-processing step and you need to remove the noise. And in addition to that, if any artifacts that also need to be removed and studied, and also we need to enhance the contrast. So here is an example. Maybe the projector has some issue, right? When you look at this image with your laptop or mobile, you can see very clearly this image. Okay, this is the original MRI image which is captured by one of the image modalities. Okay, so this is the next step is after skull stripping. So we need to extract only this portion of the skull and we need to remove this portion, and for that we need to use some pre-processing technique, and we need to do this process, and then after skull stripping we will get this image. It's not very clear to you with this display. Anyhow, this presentation material will be shared. You can take this material and you can see in your laptop. Okay, this is an example. Another example here is a original medical image with a noise. You can see here there are some noise, and even the picture quality is not that good. If a doctor looks at this image, maybe it's not possible for him to draw any conclusion out of this, and because of poor quality and also the noise here. Because I just tell you one realistic example. I had been to one of the imaging centers in Mysore. Many of you might have heard it, Karnataka Diagnostic Center. It's very near to bus stand. I think it's a very famous diagnostic center in Mysore. All the doctors normally refer the diagnostic center and there will be a lot of queue in fact. For some reason, I had been there to get the MRI images of my child actually, because I already mentioned the reason why, the first baby girl. Right, I went there as suggested by one of the doctors in the Bangalore. I took the MRI. And that MRI images has been shared with another doctor in Mysore only. Okay, so that doctor is also expertised in neurosurgery and actually pediatric neurosurgeon. And that lady said that, okay, the quality of images is fine, and she just diagnosed and she said that not that serious, everything is normal. The only thing is a little bit of very minor issues will be there, and that can be corrected over a period of time. Maybe when brain develops, because definitely there will be a developmental delay, right? Many times when when a child go to the doctor, they measure the skull, right? Okay, that gives the whether it's a normal growth or not. So she said that everything is fine with a little bit of issues, but that can be corrected over a period of time. And again, whatever the problems that is, the child is right now suffering from, that can be through physiotherapy and other things, it can be studied. Okay, that's fine, we were very happy. Again, another doctor suggested us to go with some person in Nimans. Again, that lady is also famous doctor. When we went there, that lady was telling that these MRI images are not good. She is not able to draw any conclusion out of it. What to do? See, the another doctor has said that everything is fine, no such issues, and that doctor says that no, it's not that good, you please go get one more MRI scan and bring the details. What to do? See, then I said, okay, something wrong. And again, when I was interacting with the doctor and other subordinates, I understand that they wanted the data for some research purpose, right? So because of that, they are telling this way. I understand that. I clearly make out with their, because even they said that they have to do some genetic test, right? And that genetic test cost roughly about some 35 to 40,000 rupees, just one genetic test. And then I inquired the doctor, okay, what you are going to do with this genetic test? Are you going to give treatment, or what else you are going to do with that? Then she is telling that no, we cannot give a treatment for that, but we can just tell what will happen in future. Then what should I do with that? Right, you are not going to give a treatment, but you are just finding out some genetic issues, but nothing has such in the family, right? And other doctors have also mentioned that maybe it is because of some issues during birth, right? But they wanted some data maybe for their research, and then finally I understand that nothing doing. Okay, I came back, and again I met another doctor, and those doctors who are in Mysore, they have given almost similar opinion. Then I was happy. Okay, so why I am giving all these examples is even many of you might have experienced the similar, encountered similar instances or similar experiences, right? That's why I just already mentioned that for a medical sector, for a doctor, right, ethics is very, very important. Okay, so otherwise, how can we bear, how can an ordinary person can bear that much of money, right, for a scanning and all? Okay, anyhow, let it be. This is what is the original medical image. So this is what is the image after noise removal and enhancement. Now look at here. Maybe when you compare these two, this looks much better, where doctor can identify some very minute information there and suspect something there, and again subject for some more examinations in case any such kind of minute information is present, which is deviated from the normal image and all, as per the experts' experience and the domain knowledge. So this how the pre-processing helps the medical image processing and also the algorithms to produce better results. Okay, and some of the techniques which have been studied by the researchers for a pre-processing are linear filtering, Kalman filtering, spectral subtraction technique, recurrent neural networks, and many such kind of filtering techniques, sharpening filters, median filters. Okay, so a lot of filtering techniques and even deep learning models have also been studied for removing the noise and also for extracting the region of interest. Okay, so that's how even for the enhancement as well. So the pre-processing is also one important step that you can not rule out in your research work. And another step is segmentation, and this is very important for any medical image analysis, because it is not good to analyze the entire image, but we just have to look at only the part, we call it as lesion part of the image. So that's what is called region of interest, where the doctors suspect, okay. So isolating specific region of interest from the image, such as organs, tumors, or blood vessels, okay. So many times doctor looks at the X-ray images and CT scan, they identify some such things, but that need to be very precisely segmented, and this segmented image will be subjected for examination under various other technologies like microscopic, or even we can use this part of the image for subsequent analysis, eye-end analysis, okay. So that's where we will be able to make a good decision, and that's what is an example of segmentation, okay. Segmentation of region of interest. It is still a very challenging task, but recently the researchers have proved that the deep learning models are very efficient in segmenting the region of interest after enormous amount of training with a good number of samples. So this is what is the ground truth images. This what is the experts segmentation results, and this is what is the predicted segmented images by one of the algorithms. Now you can see more or less the accuracy is more or less matches with this, right? Okay, so this how we can evaluate the performance of any segmentation algorithm with the ground truth and the predicted segmented images. If there is too much of variations in the results, then definitely we need to evaluate such an algorithm, okay, and then we have to fine tune, then we have to confirm that yes, the algorithm is producing better results, right, and it is on par with the ground truth. So till that we need to conduct the experiments, and we need to analyze, we need to fine tune the algorithm. So this what is all about the segmentation part. And another very important thing is the feature extraction. But now when it comes to this particular step, as we already mentioned, this feature extraction step may not be required in a deep learning model, but this feature extraction technique is one of the very important steps in a traditional machine learning model, where we need to identify what features need to be extracted, and subsequently how these features are used for analysis and to make a decision, right? Maybe a prediction or a classification, anything as such, okay. But as suggested by the experts, now the deep learning models will automatically extract the features, and that is the ability of the deep learning model. But for that we need a high computing power and also a lot of images, okay, and of course there are certain issues with that. So apart from that, for some of the very focused areas of research and limited, I mean, of course not that challenging, but still we need technology support for that. In that cases, definitely the traditional machine learning techniques will definitely work for it. At the time, the feature extraction techniques plays a very significant role. So now let me explain what is feature extraction. The feature extraction refers to the process of transforming raw data into numerical features that can be processed while preserving the information in the original data set. Okay, so we have an image, we can apply, say for example, LBP features, right, or GLCM features, or GIST features, or histogram features. So we can now extract those features which capture some important information hidden in the image, and those features can be used for subsequent analysis. And this is a very important step. Many feature extraction techniques, algorithms have been proposed by the researchers. When you look at the literature survey, you find plenty, okay, right, shape features, texture features, and other color features. So all these features can be used for extracting the very important information from image and subsequently for analysis. So the purpose here is feature extraction, extract key characteristic from the medical images. That is the first thing. And the type The features include shape, texture, intensity, and spatial relationship. Okay, so this information can also be extracted. But in case of a deep learning model, it directly extracts the features which we will not be aware of it. Okay, so we will get only the last layer where the features are extracted. It's only represented in terms of some numerical values. But if you understand the traditional feature extraction technique, you will be able to understand what shape features are used, what texture features are used, what intensity features are used. Now, I can just give one simple example to understand this, the shape. For example, if at all I want to classify a fruit like an apple and a banana, right? So definitely, I need not go with any color or a texture because the shape plays a very important role, right? So when I input an image which is of round in shape, then definitely I need not compare with the banana because altogether the shape is different. It's an elongated, but it's a circular in nature. So I can easily make a decision, right, without comparing with all the images. And similarly, most of the applications where shape plays a very significant role, for example, you want to recognize this word, right? How we do it? Normally we do the segmentation, right? See, unless our brain segments and understand what each and every character is, we will not be able to read this as a feature. See, but it will done in a fraction of second, even it takes less than that. By looking at this, you can say feature extraction. That is what is the knowledge what we have gained, and that is what is the experience we have gained. Now you ask a kid who just started learning English, it says F-E-A-T-U-R-E, then feature. It says like that. Similarly, it understands the next word, E-X-T-R-A-I-O-N, extraction. Right? We have trained the kid. Okay, over a period of time, after practice, the kid is able to read it fast because the brain has equipped that skill where it can segment each and every character, understand each and every word, and how these words are used to form, characters are used to form a word, okay, and then what is the meaning of that word. So all these things happens within a fraction of second. When I say feature extraction, you will automatically understand what exactly the feature extraction. But in turn, your brain has done a lot of things. That is the pre-processing, like understanding the segmentation, it extract the features because see, F and E, they looks almost similar, right? Look at here, F and E, only this portion is different, but still you will be able to understand that this is E and this is F, and that is what is the distinguishable features, right? So any text analysis will use the shape features rather than a texture feature. The texture feature has nothing to do with this character analysis, okay? And even the color information is also not required. So the shape features are well explored for any such kind of text analytics. So right, so for example, I want to convert a PDF into Word or any image text into editable text, okay? So in such cases, shape plays a very important role. So similarly, texture for studying any images, so texture also plays a very important role. And then the intensity, means the color information and the spatial relationship, okay? So all these different types of features or the characteristics have been extracted from an image that can be fused and that can be explored for analyzing an image. So that's what is the feature type. Then clinical significance, how these features are important in clinical analysis. So crucial for diagnosing conditions and predicting the outcomes. Okay, for example, in a brain, gray matter and other kind of information need to be extracted. So at the time, definitely the intensity plays a very significant role. And even whenever you are studying the pathology images of blood cells, so then you can see RBC, WBC, and it's whether it is a circular in shape or elongated, because even such shape information will tell you some abnormalities in the cells. Okay, some abnormalities in the cells, and that need to be properly understood. So while analyzing any such images, microscopic images, blood smear images, right, so then definitely the shape plays a significant role, intensity plays a significant role, even sometimes the texture as well. Okay, so that's how it has a very high significance in a clinical analysis for diagnosing conditions and also predicting the outcomes. Okay, right. And even the methods range from traditional descriptors to convolutional neural networks. As I already mentioned that if you are using a traditional machine learning algorithms, this feature extraction will be done manually by exploring some feature extractors, as we mentioned, like LBP feature extractor, GLCM feature extractor, GIST feature extractor, histogram features, okay, and Fourier transformations, wavelet features. So lot many techniques can be explored for extracting the features. That is what is a traditional descriptors, and also we can use a convolutional neural network which can automatically extract the features, having studied many example images. Okay, so with this, handcrafted versus deep learning, of course very similar to this previous one. Here we have mentioned the method, but here we are just giving it some difference. So manual design versus automatic feature learning, so we already mentioned it. Okay, next, the feature selection identifies the informative features and enhancing the accuracy. So this is what is called the feature selection, or you might have heard about the word called dimensionality reduction, right? Dimensionality reduction. So sometimes we heard that curse of dimensionality. When we have too many features, then it's very difficult for us to discriminate, and also it reduces the accuracy of the classifier. So we need to extract the discriminative features whenever we do a classification. Okay, so that's how some of the features are not that important, so hence we need to remove those features, and for that we can explore the dimensionality reduction techniques. This is the another area of research, because you can find some very interesting PhD thesis and also research articles published in reputed journals where the people have proposed algorithm for a dimensionality reduction. The best example could be a principal component analysis, which you have already studied, right? Okay, so where you project the original features into another space, like a linear combination of those basis vectors and all, and with that we are trying to understand how the data spread in along the principal components which are perpendicular to each other, and those principal components are the discriminative features which you can use. For example, if the dimension of the feature vector is 100, and when you draw or when you use the principal component analysis, so of course you will get 100 principal components, but only few principal components are orthogonal to each other, which have preserved the high variance, and you capture only those principal components and you do the analysis. So you will get highest accuracy rather than using all the features, and that is what is called the dimensionality reduction. The feature selection is also part of the dimensionality reduction, right? And also several techniques have been proposed, so you can even concentrate on the feature selection as well, right? But I did not find any literature as such where the deep learning models have been used for a feature selection. Okay, so maybe right now it may not be required, but of course the future research directions may look into that aspect as well. Okay, so why should I use those many features, right, when I am able to classify with only one or two features, right? So I think some of you from computer science background, okay, because of course I believe that everybody is come from a computer science background. So you might have studied the Boolean algebra. In that Boolean algebra, we have understand the expressions like sum of product expression, product of some expression while designing the circuits, right? So there we have a truth table where the truth table have many input variables, okay, right? So then we form an expression, and when you form an expression, some of the variables do not have any significance at all, right? For example, A into C bar plus AC, A into C, there are two variables. So the law says that A into, right, C plus C bar. C plus C bar will become 1, so that entire expression is reduced to only one input signal, that is A. Because the output of AC bar plus AC is equivalent to A only, right? That's how, instead of using two AND gate and OR gate, you can just represent that as only one input signal, and that's how it reduces the overall complexity of the circuit, right? If at all you want to design a complex circuit, such minimization, optimization is also very much important. Even in deep learning models, we use many optimizers, AdaBoost, many other optimizers are there. So we can make use of those optimizers, right, And even in a traditional machine learning techniques, we can do the feature selection. A lot of techniques are there. Even you can understand its significance for your research, and you can export that as well. So this is another very important step. And of course, this feature selection is also a part of the dimensional reduction. Reduce the complexity, improve the efficiency. Maybe it's repeated. Anyhow. So the challenges are selecting relevant features, avoid overfitting is also a very challenge that need to be studied over different data sets. Okay, so which are relevant and how it avoids overfitting. Okay, so those things are also very challenging issues, research issues. And then the integration, features fed into classification for diagnosis and planning, and that is the final step. With this, we will be able to complete the entire process of image analysis or image recognition. So these are the major steps. So when you look at the literature for each and every step, you can find some attempts by the researchers, and even the people have gone into the depth in understanding only the pre-processing techniques. You can find some PhD thesis only on pre-processing techniques. So depending upon the type of the images, you can suggest which is the best filtering technique. Okay, so there are certain image attributes. Okay, by looking at the image attributes, by automatically extracting those image attributes, you will be able to decide what type of noise is present in an image, which is the best filter, and that's how you can reduce the overall time. So that's how you can think of a research in each and every step. Maybe a pre-processing, and there is a segmentation, separate thesis on segmentation, separate thesis on feature extraction. So that's how, if at all you want to go into the depth, you can also formulate your research topic that way, or even you can consider all of these steps in one research problem. Okay, so that's how you can decide whether you want to go into the depth or whether you want to take it in a breadth-wise. Okay, so with this understanding about the various steps involved in image processing, this is just an example feature extraction model. Original image is given. Histogram features are extracted, and then meta features are also derived out of these histogram features, and that maps to a semantic mapper, and then the semantic features will be taken, and that can be given to a conventional classifier, or it can be given to a neural network classifier, and subsequently the classification happens. So histogram features are extracted from the original image, then histograms are processed to obtain the meta features, which are the input for the semantic mapper, and try to produce the semantic features, right? So now, because when we extract the features from an image, definitely those features are in terms of a number, some values, some quantities. Okay, but we call it as a raw features, but that need to be mapped into the semantic features, right? So I can measure the nose of a person, width of the eyes, and many things as such as statistical features. But how these are integrated together so that I can draw some semantic meaning out of it. Okay, that plays a very important role, because when we extract the features at the low level, it's all in terms of numbers, but that need to be mapped onto the semantic features, so for a better classification. But that is inbuilt into the human intelligence, and that's how we never look at how, when I look at a person, how features are extracted, how the features are mapped onto the semantic features, right? How it classifies. So everything is really very interesting to know, but attempts have been made by the researchers, and we are approaching towards that. Hopefully it takes another decade to understand better our brain functionalities much more, and then we can try to mimic the natural intelligence as well. Okay, so another example here is the palm print of, and a palm image of a person, and these are some interest, a region of interest extracted, right? And subsequently the gist features are extracted from by using a Gabor filter at 8 orientation at different scales. For more details, the technical details, you can study the Gabor filters and how it works and how gist features are selected, right? And finally filtered for different scales and orientation. Okay, windowing the filtered images, and then average values for each region has been calculated, that is E, and subsequently concatenating average values of all filtered images to form a feature vector from a gist descriptor. So this is how you can explore This is just an example I'm telling how different feature extraction techniques can be used to extract the features and finally used for classification purpose. And the next important step is the image registration. So image registration is also very important because when you capture an image from the same person at a different instances of time, okay, or from a different persons on the same issue or the problem, then those images need to be properly aligned or registered, and then the region of interest need to be extracted, and then only we will be able to do some analysis with that. So that's what is called the image registration. It's a process that overlays two or more images from various imaging equipment or sensors taken at different times and angles, or from the same scene to geometrically analyze the images for analysis. So here I have given some description how the detection of epilepsy is done through this kind of registrations, right? So for more details, you can just go through what is this interictal and ictal, right? So these are the states when a person is affected by the brain, like a tumor or attacks or something like that. So they are trying to capture the information at different levels, right? Because many times you see the person automatically fall down, right? And it goes to sometimes unconsciousness and all, right? So those states have been captured, how the brain works at the time, what signals have been captured at the time. Okay, so that's how left column, top and middle. So this just images captured, okay, at different instances of time, and they are registered, and finally they try to analyze that image. Okay, so this is what is written here. So top, left, and top, middle, right? Top, left, and middle, okay, are column in registered, subtracted, and thresholded in order to localize the place of scissor focus. Then the selected spec information, middle column, okay, this one, middle column, is pushed into the MRI image, the right column, registered with the left column, bottom image, okay, this one, okay, this is compared, look at here, these are registered and this part is identified, and again this is compared with this image and this part is identified. Okay, that's how registered to the original spec data, left column, middle. So this how the registration also plays a very significant role. Maybe the doctors and also the other people who have worked on this particular problem specifically with respect to a particular image data set, I hope they will be giving you a more detailed analysis and also the procedure related to how image registration happens. So definitely this could be one of the interesting tasks as a part of your research work if you are going for any medical image analysis task. Okay, so just keep in mind this also, and you can explore much more regarding that. Okay, so with this, now the next step is the analysis, where this involves using the extracted features to diagnose diseases, assess treatment response, or plan surgeries. So having analyzed those images, then the doctors are going to suggest you some treatment. Maybe it can be cured through a medicine, or it requires any surgery. So all such decisions can be made only after analyzing these images. Okay, and to draw that conclusion, all the steps what we have just now mentioned are very much important. So finally, the visualization. This involves creating 3D models or other visualization representations of the image data to aid diagnosis and also treatment planning. Okay, so these are the major steps involved. So please remember, and you can find some very interesting literature in this direction, and accordingly you can define your research problem gaps, and subsequently you can work on your problem. So with this, applications of medical image processing in healthcare. So diagnosis we already mentioned, treatment planning, monitoring, and also for research. So monitoring means medical images can be used to monitor the progress of treatment and detect any recurrence of diseases, and that is the reason the doctors are suggesting you to go for a multiple scanning once the treatment is given to you, right? For example, a person has taken a treatment for some reasons, for some ailments. After 6 months of treatment, what is the status? Again, the person will be subjected to such kind of imaging modalities. Then they study the images, and then they make a decision. and particularly the orthopedic. Okay, so for example, if some fracture happens to a particular person, right, and treatment has given to a person, and after treatment has given, okay, maybe for about 6 months or so, what is the status, right? Whether the person is now almost cured from the problem or still some more treatment is given to them. So all such kind of analysis, monitoring, everything is done through the medical image processing. So the research, as we all know, medical image processing is used as a variety of research applications such as the development of new diagnostic tool and treatments. Okay, so when you visit any medical hospitals, right? Medical hospitals, you can find a lot of tools and also the devices which aid the medical analysis, right? So we can do research and development. By doing that, we can also come out with new diagnostic tools and also the treatments. Okay, for example, given an X-ray image, as we already mentioned that, for example, if at all I want to zoom up, right, I can just zoom up and I can see, and I can zoom down, right? So a lot of things, so such tools can be created, right, through a research, right, and it helps for subsequent analysis and the treatment. So these are some of the applications. Okay, so having understand this, now I would like to draw your attention on some data sets used in the domain of healthcare, because in the research question I have mentioned this also, right? A knowledge about the data set and what data set the people have used in the research work and what articles have been published. Okay, such information is also very much important and relevant in this context. So one such data set is DDSM data set, the Digital Database for Screening Mammography, DDSM, is a popular large-scale mammographic data set released in 1996. The data set contains 2,890 cases, including left and right craniocaudal CC and also mediolateral oblique MLO views for a total of 11,560 mammographic images. Okay, this is what is the data set. Okay, you can download this data set, or this data set is available, publicly available, and that can be used for studying your algorithms. Okay, so whenever you are working on this data set, you need to understand what is the state of the research done on this data set and what is the result that has been claimed. Okay, suppose if the most recent literature says that on this data set for for classification, right? Okay, for masses classification or any other detection and all. Okay, so in that case, if they have claimed an accuracy of, say for example, 90% or 92%, then definitely we have to identify for what cases the system has failed. Okay, how can we improve the result, right? It is not that 90% accuracy means that the system can be deployed, okay, because 10% error is there still. Okay, so we need to identify that 10%, what is the reason and how can we overcome that, and if you do so in that direction, the research, then that is really very interesting and very useful research, rather than telling that the literature says that 90% of accuracy and my algorithm produces 91% of accuracy. Right, so just 1% of accuracy, we are going to do a lot of circus, right? But instead of that, the true research says that what is the cause for remaining 10%, right? So that's why we study normally the confusion matrix. You know the confusion matrix. For example, X is classified as Y and Y is classified as Z. So there is some confusion, right? So for what classes there is too much of confusion. If we are able to understand that confusion between the classes, then what features make them to confuse? So that we need to identify those features, remove those features, and then we can do classification. Hopefully we can address that misclassification or confusions. So that's why we normally present the confusion matrix when we are evaluating the classifier accuracy, right? Okay, so that's how when you are working on this data set, the thing is we need to understand the state of the heart work and what is the results claimed, and another, how can we improve the result. So, and very recently we have noticed that most of the time, because of this paid journal or articles published in non-reviewed journals, okay, so they simply claim that 99% of accuracy. What is there to do research then? Already they have claimed 99% of accuracy. So it's for another 1%, what we should do? So definitely there is a question, right? And most of the research, survey you see, they almost say 96%, 97% and 99%. So, and we don't know whether the facts, what has been presented in those papers are really the facts or something else. We do not know. Okay, my suggestion is, if at all our research need to be accepted by high-end journals, they should release the code as well. I think now they are telling that you have to release the code, the executable code. You need not give your algorithm, you can patent it, right? And you can keep your copyright with you only. You just have to give a working model, right? Anybody else can check. Because you have claimed that for this data set your algorithm has given 99%. Let's check anybody, right? We should have that courage, right? Suppose if that is the case, then we can accept it. But most of the time what happens now, we read the paper and we say, oh, 99% already, there is no scope in further research. Strictly speaking, if you implement that algorithm and see, you will not get more than 75% of accuracy. Many times it happens, right? That's why my suggestion to you is better study the peer-reviewed journals, okay? Good journals where the papers are peer-reviewed by the experts, okay? Otherwise, your research will be definitely misguided. Your research will be misguided, right? And I don't think that's a true research. That's a true research, okay? So please, and many times what happens, no? For example, the algorithm has been studied on this data set. For example, for some other data set, for the same purpose, the algorithm may fail, right? The algorithm has reported 98% of accuracy for this data set, and for same purpose, we have collected another data set. For that data set, that algorithm may produce 80% of accuracy, right? Then what is your conclusion? Whether there are more challenges in the data set, or whether the algorithm is not that accurate, right? So definitely there is a scope for analyzing all those things. So that's why most of the times what we do is we conduct an experiment on this data set just to say that whether my algorithm works better or not. But the true research lies on any data related to this, and expecting the same claimed performance by your algorithm. Okay, for example, you have claimed 98% of accuracy for this data set. For whatever the data set I give related to this, if your algorithm produces the 98% of accuracy, then that's really a wonderful research, right? So that's what is really expected, but we have to think in that direction, okay? So because there are a lot of issues, right? We did not discuss those things, right? N-breast data set, this is another data set. Again, it's related to mammography only. It is a full field digital mammographic repository made public by the hospital de São João in Porto, Portugal in 2011. The dataset contains a total of 115 cases, 410 images, from which 90 cases are from women with both breast affected, 4 images per case, and 25 cases are from mastectomy patients, 2 images per case. Several types of lesions, masses, calcification, asymmetries, and distortions were included. Accurate contours made by specialists are also provided in XML format. So this is another data set. Now look at here, DSDM data set, in-base data set. We need to understand the purpose of creating these data sets and which data sets we need to use and for what purpose, and that is also good knowledge for researchers to proceed further. And subsequently, another is a BCDR data set, breast cancer digital repository, contains cases of 1,734 patients with mammography and ultrasound images, and clinical history, lesion segmentation, and selected pre-computed image-based descriptors. Look at here, selected pre-computed image-based descriptors are also given. The patient cases are Berad's breast imaging reporting and data system classified and annotated by the specialized radiologist. The radiologist have already given you the ground truth because they have already done the classification. For this data set, what we need to do is we have to design algorithm so that our results are compatible with the results given by the specialized radiologist. So that's how we can evaluate our algorithm on this particular data set. And once our algorithm is found to be good in terms of accuracy and efficiency or robustness with respect to this data set, with respect to the results what has already been given by the experts, then we can try that algorithm for other data sets for a similar cause, and then we can see what is the result. Okay, so this is how the research need to be done in an evolutionary manner. So apart from these data sets, I also found some other data sets. I have also mentioned the website information here. MR Brain, yes, so this is the website. You can go to this and you can get more details and you can download the data sets. Okay, and these are MRI images of the brain for tasks like segmentation and registration, focusing on multiple sclerosis research. Okay, sclerosis research, right? So this is the reason. So this is the data set. Retinal fundus images for glaucoma analysis. Okay, right? So during lunchtime, one researcher has, yes, you know asked this, right? Yeah. Retinal fundus images for glaucoma analysis. So I have shown you the fundus images, right? A fundus camera and fundus images, right? So you can go to this website and you can find out this, right? Retinal fundus images for glaucoma analysis, aiding in the development of algorithms for early glaucoma detection, right? So early glaucoma detection, we can use this technique and the data set for analysis. And similarly, cancer imaging archive, this is another data set. You can go to this website and get it. Large collection of medical images related to cancer research, including MRI, CT, PET, and also pathology slides. Okay, pathology slides. So this data set is available and you can download and you can use it. And medical segmentation decathlon, MSD, this is the website. Benchmark data set for evaluating segmentation algorithm across various anatomical structures and imaging modalities. So this is basically used for the purpose of segmentation algorithms, to study the segmentation algorithms. Alzheimer's Disease Neuroimaging Initiative, ADNI, this is the website. And MRI, PET, and other imaging data related to Alzheimer's disease research, including images of both healthy controls and patients with Alzheimer's disease. Okay, so you can study what is the level and what is the severity, right? All those things can be revealed with this, studying these images, and any early care can be taken out. And medical image computing and computer assisted intervention, MICCAE data sets, and these data sets are used in the annual MCCAI challenges covering tasks such as segmentation, registration, and classification. Look at here. So they have released these images as challenges. Okay, so segmentation, registration, and classification. Even the VGG deep architecture is result of one of the challenges. So they have proposed that architecture to meet one of the challenges, and now that has become very popular deep learning model. So that's how these images are very challenging images. Maybe there are certain scope for you to improve the existing segmentation algorithm, registration algorithm, and also the classification issues. So what we need to do is, for which images in this data set, the current state of the algorithm fails to do the segmentation. So catch hold of that and try to improve that algorithm by either augmenting the existing architecture or altogether proposing a new architecture, and that is what is the real contribution to the field of research. And similarly, the registration, right? So my understanding and suggestion after this experience is, we should not initially try to work on the entire data set. Just conduct an experimentation and try to understand with the existing literature survey for which cases the system has failed. Okay, the failed data example cases need to be taken, and we need to work on that particular image and try to resolve the issue, right? If your system works for that, definitely we can expect that it works for others as well. Okay, that's how. So that's where we can speed up the research and we can concentrate more on the very challenging issue which has not yet been addressed by the other researchers as suggested in the literature, and taking up that challenging task, working on that, proposing a new model or any suggestions as such or any fine tuning for the existing architecture, and that really helps a lot to get a good publication, right? And that's how we can think of contributing something to the field of medical image research through even a small contribution. And similarly, it's true with classification as well. Okay, so that need to be done. So lung image database consortium, LIDC, CT scans of the lungs along with annotations of nodules primarily used for lung cancer detection and diagnosis. Okay, I think some research scholar is working on this, right? And you can look at this database, and also you can find how many images are there for you to study and other things. Then medical image net, maybe you might have heard about it. A large-scale data set of medical images covering various categories and modalities inspired by ImageNet. Again, it is a deep architecture where they have prepared a lot of medical images data set covering various categories and modalities, and even you can make use of this for your initial research. And later you can fine tune and you can go to the depth and you can do it. So these are some of the popular medical image data sets which you can find. And apart from this, sometimes you have to create your own data set. Okay, you have to tie up with any medical hospitals, and you need a domain experts for that. And then you have to collect the images and do the pre-processing and make it official with all the formalities, and that will be used by other researchers as a standard data set. Okay, so that's how we can also contribute to a certain extent in creating a data set, okay, where we can expect the algorithms should work on all those wide varieties of data set created by many researchers, and that makes the algorithm much more robust. So with this understanding, now the next few slides are just for statistics. The percentage of modalities used in medical imaging, this only for statistics, okay, just for your kind information. MRI or X-ray, 45%. I mean, 45% of the research has been done on MRI and X-ray, according to some survey. 30% on CT scan, right? And 10% on mammogram, 5% on ECG, and only 10% on eye scan too. Okay, so maybe this also helps you to explore in case if at all you want to start your research, you can think of, okay. So maybe some useful statistics by one of the researchers who has done a survey paper on this. Percentage of tools used for medical image analysis, percentage of tools. So TensorFlow 12%, numerical Python 37%, MATLAB 38%, R 13%. Okay, so maybe this is almost 2 years back statistics. Maybe recently we can expect some more changes to this statistics, because very recently the people have explored TensorFlow more. Maybe we can think of increasing this, right, when compared to other, okay, MATLAB and all. Because earlier when we were doing, MATLAB was very popular. We were not using, because we were not aware of TensorFlow or NumPy techniques that time, and we were using MATLAB, and that's how the percentage of usage is 38%. But now this has gained a lot of popularity. NumPy and TensorFlow, maybe this statistic will be changed. And then percentage of various techniques used in primary studies. Okay, now look at here. Random forest is for 9%, and transfer learning again 9%. Support vector machine 20%, right? WB, forgotten this expansion for this, 2%. ANN, CNN, that is for 14%. Decision trees, again, yes, 4%. And BaseNet, okay, and ML, PCA, ISA, and others, they all covers the remaining percent of, right? Again, This will give you some useful statistics regarding how different algorithms have been explored for medical image processing for various data sets and all. And another is the percentage of multiple diseases diagnosed in the primary studies. Okay, brain tumor 18%. Okay, high diseases 3%, diabetes 16%, liver 3%, lungs 16%, heart disease 5%, hepatitis, cancer, skin disease, multiple diseases, and subsequently they are shown, right? I think hepatitis is also like to one of the categories. I think the color, yeah, is not that clear. Okay, of course there is some difference, but anyhow, it's not that clearly seen, right? Let me just some information, statistical information regarding this. And then statistical analysis of ML and DL techniques for medical image analysis. Okay, so again they have put together, see here, this DL technology and ML technology, this much, DL is this much, right? And you can also see the various percentages, right? Okay, so anyhow, this slide will be with you and you can go through it and you can understand transfer learning 5%, CNN 5%, and ANN 35% and etc., right? So you can just look at this statistics also. So with this, now I just wanted to show you some results by ML and DL techniques for medical imaging, which I got from very recent survey information. But I have included only a few. I think there were much. I have included the survey, reference paper in the last slide. Maybe you can go through that and you can get this paper. In year 2016, CAD-based CNN, computer-aided diagnosis based on CNN, is produced. And these are the parameters they have used: sensitivity, specificity, area under curve, multi-view features, human diagnostics, and etc. And this has been studied for breast cancer classification, benign and malignant. And they have reported that sensitivity of 88.6%, specificity 87.6%, area under curve is 0.9468. Okay, so for this, I think we have not mentioned the data set here. Maybe in that paper they have mentioned the data set. So for that data set, they have claimed this result. Okay, so you can just, based on this, you can think of what is the scope for further research as far as this is concerned. And in the year 2020, the techniques proposed are used: deep learning and machine learning, the accuracy, precision, F measure, area under curve, again for breast cancer. Look at here, they have worked on 3 data sets: DSDM, InBreast, and BCDR. We have already mentioned. Accuracy 97%, area under curve 0.99, similarly 95%, 96%, right? Okay, so by this, any reference is given at the end. You can please look at it. So this is the state-of-the-art survey results. Similarly, ANN, image features, again breast tumor accuracy by SVM 77%, random forest 78%. Still there is a scope of 23% improvement in the results as far as this work is concerned. And CAD, transfer learning, and fuzzy feature selection and correlation feature selection. In the year 2020, some have proposed handcrafted features. Again, breast tumor, benign and malignant accuracy. They are telling that benign is 100%, malignant is 96%. So this can be explored further, and we can work on that. And similarly, in 2017, CAD, naive-based SVM, and functional trees have been used or proposed. Handcrafted features for identifying heart disease, diabetes, liver, dengue, and hepatitis, and they have reported this much of accuracy. Right, heart disease using SVM 94%, diabetes using naive 95%, liver disease uses functional tree 97.1%, etc. Right, and similarly, iScan2, integro differential operator, rubber sheet normalization, 2D WT. So these are some of the methodologies and mathematical concepts that have been explored to study or to propose the algorithm or to propose the solution to the problem. And again, subsequently, the classifiers like binary tree, random forest, SVM, NN, etc., right, AdaBoost, and then accuracy, specificity, sensitivity have been used, right, for measuring the performance of the algorithm or the classifier. Diabetes is the disease which has been classified. and they have reported accuracy only 15%, specificity 96%, sensitivity 98%. See here, there's only 59%, still 40% scope is there to address this by using iScan2, right? Okay, so you have just asked, right? So how iScan2 is used? So maybe you can look at this paper. You will get more information regarding this. Still there is a scope, okay? Because specificity and sensitivity are just for a true negatives and true positives, such kind of thing. Okay, but the overall accuracy is 59%, 63 only, almost 60%, still 40% scope is there for you to work on this. And that too with these classifiers. So more details you can find out. So with this, accuracy results for MRI images using ML and DL classifiers model. So CNN, RF, SVM, DT, LR, okay, linear regression model, ResNet 50 V2. So they have reported these results, okay. 97, 96, but I forgot to mention for what results, but however, they have reported the state-of-the-art survey reports are some data sets, but it's worth mentioning for what data set and for what disease these results are classified. So that is missing here. Anyhow, you can please refer that paper. Again, this ML and DL types based on type of disease. Breast, brain, lung and diabetes. They have explored ML, DL in all the cases, the techniques. And similarly, they have used machine learning technique like ensemble by using all this. Okay, and CNN, SVM, naive Bayes, CNN, transfer learning, supervised machine learning, and deep neural network, random forest and linear regression, ensemble model, CNN. So these are the techniques which are used for these things. So you can understand the current state-of-the-art work explored by the researchers in this direction. So with this, the challenges, having studied this, the challenges are to cope up with image variations. To cope up with image variations, learning from weak labels, and interpreting the results with accuracy for the diagnosis of cancer through given medical images. So this is what is challenging. Okay, so the researchers have given their opinion that cope up with image variations. For example, if we capture the images of the same person at a different instances of time or a temporal information, so it poses the challenge of image variations, and that definitely affects the overall analysis, and that need to be taken care. Okay, so that's how this another challenge. Learning from weak labels. Okay, so sometimes if the annotation is not done properly, or if there is any bias for some reason, then again the results will be different and varying. So that also need to be understood properly. Interpreting the results with accuracy for the diagnosis of cancer through given medical images. Okay, for example, for the particular medical images, you are getting some results, say for example 90% or 97%. For example, if I introduce some variations in the image or some other instances, whether the system produces the same accuracy or getting the same accuracy or same interpretation is a very challenging. So some variations will also be there in that. Okay, how are these variations are addressed? So still there are a lot of challenges for you, and you can also reduce the overall burden on the deep learning models just by feeding billions of images and taking a lot of time. I think most of the times our researchers cannot experiment with your laptop, right? You can just see, you work on any deep learning models, your laptop will not support. Okay, it may take more than 3 days or 4 days. You just keep on training, and sometimes it will give an error, and you will not be able to understand why that error has popped up. Okay, again you have to retrain the model. So it's really a very tough task, because what the research maybe a decade back is altogether different. There is a drastic change in the research, okay, the approaches and all. Now I will definitely tell you that, so now doing research, a quality research with all this is really a challenging task, even though we have a lot of advancement here, because a lot of things have already been solved. Okay, it's something like that. You have almost climbed 70% of the mountain, like Mount Everest, but the remaining 25% is it's very, very challenging, because The first 100 feet steps or 200 steps can be easily climbed, but the remaining is there, no, it's very, very challenging. But now you are in that peak, right? Definitely it requires a lot of effort from you to do that. Okay, that's how these are very challenges, but I can just give you some simple example ideas and the analysis. Okay, because I normally think that way, but we need to experiment whether it works or not. For example, I have 1,000 images. Okay, 1,000 images I have. So normally whenever I want to train my machine learning model or a deep learning model, what we do is we just give all 1,000 images, we train it, and then the model will be trained. And for any new sample, the system is able to classify. So my question is it required to train all 1,000 images or all 1,000 samples? Okay, right? So strictly speaking, in reality, it's not required. Okay, for example, you take a text data times New Roman, you take letter A, right, or letter B. Any thousands of samples which you find, okay, related to letter A in times New Roman, it's same. Is it not? Only one sample is enough. Similarly, B, one sample, C, one sample. So what is the best thing is so we can take 1,000 samples and we do clustering initially, right? You do clustering. When you do clustering, it will group the images into various clusters. Out of 1,000 samples, you may get some 50 clusters. Now take some random images from each cluster, train the model and see the performance. Suppose if you are getting more or less the same performance of training the model with 1,000 images, and if you are getting the same more or less accuracy with only limited training, maybe definitely you can adopt that idea. Okay, so it definitely reduces the burden of training billions of images, right, and also the processing time. Okay, so with limited computational resources and all. So we need to think in that direction, and what are all the possible ways where we can reduce the overall training time and training data volume and etc. So maybe we can think in a different way. That's what the suggestion. And the conclusion, transfer learning was used to cope with image variations. Now look at here, again they have suggested transfer learning was used to cope up with the image variations. The concept of multiple instance learning, MIL, and weighted transfer learning were used to overcome the weakly labeled data and improve the accuracy of the disease classification for better medical results respectively. Now you can look at this idea. You can look at this idea for other image data sets. You see, for what image data set this idea has been explored, and because they are telling that it is successful, maybe you can try this with other data sets as well. Okay, and you just see, compare the state of the results with your results. So that's how you can show the community that a new way of solving a problem. Okay, and even many times we also think in like dependent features, right? Dependent features. Okay, so identifying the dependent features also plays a very significant role in discriminating one sample from another sample. Okay, but how dependent features can be extracted from a deep learning models and all is still no one has addressed. We can think in the direction as well. Okay, so for example, if I put a signature, right, there are certain features which are very unique to my signature. And if madam put the signature, there are certain features which are very unique in spite of any number of instances, right? Any number of instances. Even you can ask me to put a signature 1,000 times, some features, some example, some very interesting features will remain as it is. So that is dependent to me. Similarly, some other features are very much dependent on somebody else. So is it possible for us to understand those dependent features? Okay, so if we are able to understand those dependent features, then altogether our architecture itself will be something different. Okay, our deep learning architecture or our machine learning architectures, that itself will be something different. So we need to think in the direction as well. Okay, so with this, now for another 10 minutes or so, okay, I try to briefly give you a computer-aided breast cancer detection and classification in mammography, a comprehensive review. This is a 2023, right? 2023, mostly February only. I just accidentally got this paper. Okay, so you can just look at this one, but I forgot to put where it is published. 23 February, maybe 10th February it seems. Very recent literature. But I forgot to put where it is published. Mostly MDPI. Sorry, 20, so 23, sorry, not recent, 23, almost 1 year, sorry. Now it is 24, right, almost 1 year, sorry, not very recent, 1 year back, 1 year back. So, MDPI, I think, the journal, okay. So, this is what is the workflow. Detection and classification of breast microcalcification using deep learning, okay. So, this is the description they have given, okay. So, digital mammographs are the input. So, pre-processing of digital mammograms, see here, right clipping, cropping and removal of noise, region of image extraction. So, these are comes under pre-processing, which I have already mentioned. And feature extraction and analysis, deep features using ResNet 18 architecture, and also normalization and analysis has been done. And then detection and classification of mammograms, they have used improved Crow search optimized extreme learning machine. Right, see here, improved Crow search optimized extreme learning machine. So you can find many such kind of ideas, right, so proposed by the researchers, okay. So because all these things are interesting, but we need to understand the mathematics behind that, okay. If you don't understand the mathematics, then we just can use it, but we will not be able to understand the stuff behind that. And accordingly, normal, okay, and then abnormal. If it is abnormal, then benign and malignant, and then performance comparison. So this is what is the workflow they have followed in this paper for detection and classification of breast microcalcification using deep learning. Okay. Now, I just show you the overview of state-of-the-art pre-processing techniques for mammogram analysis. Just a pre-processing technique for mammogram analysis. Only the pre-processing technique. State-of-the-art. One is conventional, feature-based, and deep learning-based. Okay. Unsharp masking by this person, Chan et al. Optimal adaptive neighborhood processing by Dhawan et al. Okay. These are the two works. And then Schobel filter, histogram equalization, contrast limited adaptive histogram equalization, morphological operations and thresholding. Now look at here, histogram equalization, contrast limited adaptive histogram equalization. If you are not able to understand what exactly is the histogram equalization, we are not able to propose this. Okay, that's why most of the times I suggest the researchers, why there are different deep architecture, why there are different YOLO algorithms. Right? Every time they improve, what is that improvement? Why they have done that? If we are able to understand that, we can also come out with our new architecture. So 100% sure that in future the research in medical image processing or in any image processing domain, it is altogether coming out with a new architecture which best suits for your problem. It is not that I am proposing a new feature extraction, I am proposing a new pre-processing technique, or I am proposing something else. Nothing like that. I am altogether coming out with a new architecture, right, which best solves my problem. I am not interested whether that architecture will solve somebody else's problem. I need not worry. But for my research problem, this is the best architecture. So that should be, or that will be the research in the coming days, according to my understanding. Because having studied a lot of research progress in this direction, so that's what I understood, and that is true as well. Okay, so this is what the conventional, the feature-based wavelet transform has been explored by Lene et al. And Chaudhary and this one. Now you can see he won the survey also. I mean year. And phi transform, hexagonal wavelet transform, fuzzy set theory, round high emphasis technique of fractal modeling. So they also have been studied. And for deep learning, convolutional neural networks have been studied. Okay, so a little more recent. Okay, convolutional neural network for deep learning based model for a pre-processing. Okay, that is for pre-processing. Now, what you can do is, for example, if at all you want to propose any pre-processing technique for your data set, okay, what best you can do is you take out the most recent, maybe for example 2020, and see what is the result obtained by this, and your research starts from that point actually. Okay, your research starts from that point, because we always look at the most recent work, and from that what is the limitation, what is the gap, and then we have to start working further. Okay, that's how we need to identify the gap. And overview of state-of-the-art features extracted from diagnosis of breast abnormalities in mammograms: the shape, area, compactness, density, perimeter, extent, eccentricity, orientation, and solidity. So this is with respect to the shape. First order statistics: entropy, kurtosis, skewness, smoothness, standard deviation, variance. Gray level co-occurrence matrix, contrast, correlation, energy, homogeneity. Gabor filter, features extracted from Gabor filter bank processed image. And then wavelet, okay, so features created using the wavelet transform. So this is for extracted for the diagnosis of breast abnormalities in mammogram. And when it comes to classification of breast abnormalities, the feature based SVM, MLP, right, multilayer perceptron, random forest, artificial neural network. So when it comes to deep learning, GoogleNet, ImageNet, convolutional neural network, and also Inception, ResNet V2 by this author in the year 2020. So these are the state-of-the-art classifiers used for classification of breast abnormalities in mammograms. And similarly, we have state-of-the-art algorithm for the detection of microcalcification in mammograms using feature-based machine learning. Okay, now look at here. They have used the database also, which databases, and type of images, number of images, classifiers, SVM, KNN, ANN, SVM, etc. And the validation method, you should understand what is meant by tenfold cross validation, fourfold cross validation, leave node classification, etc. Okay, and then the results claimed accuracy and sensitivity and specificity. So the complete information is given as far as microcalcification is concerned. All these details are very much required for you to write an article and work in the direction, and definitely any peer-reviewed journal expects you a comparison. So without comparison, they don't accept your paper to publish in the article. A comparison with state-of-the-art is a must to get your article published in a peer-reviewed high-impact journals. And similarly, we have state-of-the-art algorithms for detection of microcalcification in mammograms using deep learning. So earlier is the machine learning. Okay, so this is for a deep learning. Now look at here. With the deep learning itself, database is restricted. When I say restricted, it is their own data set. They are not available for you to work on. So even if you work on some other data set, you cannot compare, because they have reported their results on their data set, and you have not worked on their data set, then you cannot give a comparison. So no fair comparison is possible in such cases. This is open access, MIAS, open access, DDSM, we already mentioned open access in breast, and again, yes, all these are open access, you can use it. Number of images are there. Data augmentation, yes, they have done some data augmentation. And also classifiers, they have used CNN and validation method, and finally the results. So of course, you can have, you have some scope to work on this, because they have reported this result. Still, you can improve the results. And then this is for classification. Earlier is the detection, and this is for a classification. And again, using a machine learning, you can see the databases, number of images, and validation techniques, the reported result. And similarly, the deep learning, okay, you can see the results here, right, for classification of, so microcalcification. And similarly, detection of breast masses using machine learning, and similarly, detection of breast masses using deep learning, and also classification of breast masses using machine learning, and classification of breast masses using deep learning. So this is a little more comprehensive survey by one of the authors, right? So maybe useful. You please read this paper and understand much more. I think it's almost some 30 pages article. Okay, you can read and understand. So with this, in summary and conclusion, this presentation attempts to provide an overview of various machine learning and deep learning approaches for disease diagnosis, along with the classification, image modalities, tools, techniques, data sets, and challenges in the medical domain. So that's what is the objective of my presentation today. And MRI and X-ray scans are the most commonly used modalities for the disease diagnosis. Among all the tools and techniques studied, MATLAB and SVM dominated respectively. By now. Maybe recently these statistics can be changed. A series of experiments using MRI dataset has provided a comparative analysis of machine learning, classifiers, and deep learning models, where convolutional neural network 97.6%, random forest 96.93% have outperformed other algorithms. And due to the superior performance of deep learning approaches, right, have recently become quite popular among the researchers. And this review will assist healthcare community, physicians, clinicians, and medical practitioners to choose an appropriate ML and DL technique for the diagnosis of disease with reduced time and high accuracy. So this is what is the final conclusion. So with this, to conclude this session, let me quote this: machine learning can't get something from nothing. What it does is get more from less. So this is what we need to understand through our research. Another Nobel Prize winner has said that research is to see what everybody else has seen and to think what nobody else has thought, because each one of us have that capacity. So we don't know how we think, what is our perception, right? Everybody was saying that apple was falling from the tree, but nobody knows that it is because of gravitation, right? But that great person has understand that some force may be there, that's why it is falling. So that's how each one of us have such unique ability within us, right? So we need to extract that through our research, and that's what is the meaning. So with this, these are some of the references I could not list out. There are many more, but I just mentioned a few. But when you get these papers, in turn you can find many more interesting research articles. But my suggestion to you is, please go through the most recent articles published in IEEE, ACM, and DBLP, and Springer, where the papers are reviewed and the facts and figures are more accurate. But other papers, I'm not sure. Sometimes it may mislead us, because even we have experienced it. So that's the suggestion. Please go with only the peer-reviewed journals when you start your research work. Okay, so with this, thank you all for your patience listening. Right. Before I wind up this session, I must thank the organizers of this FDP, and special thanks to Professor B.H. Sekhar sir for having invited me for this session and allowed me to share my little idea in medical image processing with you all today. In fact, even I learned a lot of things, because from the first 3 days I was searching for the material. I think I have read almost 15-20 papers, right? Because I could not read into the depth, because I have not worked much on medical image processing actually. Okay, so I just wanted to understand. In fact, I refreshed myself. I do understand a lot of things. Maybe the reasons could be many things, right? But still, I am very happy that I could read something from past few days. I also understand along with you. So I thank once again Professor B.S. Sekhar and the organizing team and the university and also the ATAL for having given me this opportunity to share my little knowledge with you today. And also I thank all the participants for your patience listening, because almost you have listened to me for 3.5 hours. So because I could see, even I have delivered lectures on various occasions. For the first time, I am very happy that each one of you have listened to me, and also you were very alert and highly disciplined. And that's what is really expected from the researchers, okay? The patients working with a machine or working with the people and all. So thank you very much for all the support and the cooperation. And I wish all the best in your research and the future endeavors. And I'm sure that the next few days your stay here will be very, very pleasant and fruitful, because I have seen the complete schedule which was shared by Professor B.S. Shekhar sir. I understand that lot many experts are coming over here, and in fact I am also very much interested to sit with you to learn, but because of some responsibilities, administrative responsibilities and other responsibilities, I am not able to stay with you, because Shekhar sir was my best friend and I wanted to stay and work together and learn together, because from the past almost 35 years we were together, studied our graduations together, did master's degree together, did research together, got appointment together, and still we are together. Thank Almighty, we'll be together forever till the last breath. Okay, so thank you, Professor Shekhar sir, okay, for the opportunity. And also I thank our other best friends, Madam Sharmila Kumari, Dr. Sharmila Kumari Madam, and also Bharati Pillar Madam. Okay, because most of the times they are also supporting and they are also inviting us for such workshops, and they are also supporting us when we conduct such kind of academic events in our university. So thank you very much for all your support and encouragement. So with all this, thank you very much. So please feel free to ask any questions or any clarification. I try to answer your questions if any. Okay, so yes, please.
Sir, you have discussed a lot of data sets, but can you suggest some good data sets for eye disease detection, that of frontal eye disease?
Yeah, I have already mentioned one example data set for fundus images. Okay.
So fundus images, but those are for regarding the back end and internal sections, but is there specific data sets for detecting the frontal eye disease?
Yeah, I think we have seen eye scan too.
Yeah?
Eye scan too.
Eye scan.
Eye scan to the device. I think I have mentioned, I think that time you were not there, it seems. I have mentioned one example data set, right? You can explore it. So in case if no such standard data set is available,
yes,
maybe you can associate with some high specialist doctors.
Yes.
Okay, so you can do a collaborative work. Anyhow, a lot of patients will be visiting the doctors, no? So with some memorandum of understanding with the doctor or some collaborations, and even whenever you are publishing your research articles, you can even mention their name as an author or an acknowledgement. Yes. So if you work collaboratively, you can create your own data set. Because most of the times it happens like that only. Because even some data sets are available, they are not giving the data set for us, because that's what we have mentioned, restricted. So they are not providing a data set for you to work on, right? So definitely it's good if it is possible for you to prepare your own data set for whatever the problem you have defined as a part of your research work, okay? But the only thing is, and even if the data sets are not available, even you can put, that is also a contribution of your research. You can make one paper, one chapter where basically focused on the data set, where you can explain the complete process.
Details of the data set.
Yeah, how you have created your data set, what is the experimental setup, right? And how you have pre-processed your data set, any normalization you have done, any other pre-processing, resize, everything has been done, okay? So with all the details, technical details, you can document it and you can put it as one chapter in your thesis, and you can release your data set. Okay, maybe for public.
So people also can publish the data set. As
yes,
you publish the other works, can we publish the data sets also?
Yes, definitely. Definitely. Other researchers, then they will cite you.
Yeah, real data sets.
Definitely. So whenever your data set is cited by any other research articles, definitely you will get a citations, and that will be reflected in your Google citation index, right? Okay. Google Scholar citation index. Yeah, that's how. Right. So definitely, I think, particularly for a medical image processing, no. Of course, some data sets is available. It doesn't mean that serves the purpose. Maybe you may have to create your own data set, but in case if it's very difficult for you, there is no support or something like that, so then obviously you can work initially and later you can think of, okay, publishing, So definitely, in case if at all you want to publish a good article in IEEE or ACM and all, so you need to work extensively on different data sets and do the comparison and comparative analysis and show to the community how the algorithm behaves across data sets and other things in real time. Okay. Yes, ma'am.
Likewise, if you just create the data set for that also, we need to give the reason also. Like what could be the reasons?
No,
like we
because
have.
For example, sometimes you don't get the data set for your research work. Say for example, you have defined altogether a new research problem. I will tell you my own example experience. I worked on fuzzy symbolic approaches for two-dimensional shape analysis applications. But I did not get a good data set which can truly explore the strength of my algorithm in reality. So I just wanted to create my own data set. So I just did it, and in fact in my thesis I have listed out whatever the images I have created as a data, but I have not published it. Okay, why we have created it and how it justifies the significance, right, in my research context. So that I can explain. Okay. And even we have created one medicinal plant data set, medicinal plants. Okay, so we did not find exclusively the medicinal plant data set. Right, generally leaf data set were there, but exclusively medicinal plant data set. So we just did some field study, and we have collected some roughly about some 50 different medicinal plants data sets, and we have used in our research work. Right, we wanted to increase that, okay, to 100 and 200 or 300, but it requires a lot of field work. Okay, so definitely we can say for our research, good data set is not available, and hence it is inevitable that we have to create our own data set, and that could be the reason. So maybe even sometimes some standard data sets are available, but they are not, they are restricted, so they are not available to use, okay, by the public, right? That way also, right? Even you can highlight some of the limitations of the existing data sets for your research perspective. Then because of that you want to create a new database. So that's up to your wish, but justification in case if at all you want to publish and you want to publish articles in a good journal. Of course, a comparative analysis with the other data bases is also required in addition to your own data set and justification for it. So that's true. That's true.
Thank you, sir.
Sir, can we integrate quantum computing and deep learning using IBM Qiskit toolkit?
Sir, yes, sir, that we need to explore, because now recently the quantum computing is gaining a lot of attention. I did not find a good, I did not do a good survey on that. Right. Definitely we can think of, because deep learning models requires a lot of computational power.
Yes.
If you switch over the paradigm to quantum computing, definitely it reduces the overall burden of the overall computational complexity. But we need to look into that, whether any work has already, is in that direction. Maybe if we get a little bit clue in that direction, hopefully we can think of. I'm sure that in coming days the people will definitely switch to that.
That's the only one option.
Yes, definitely to that computing, paradigm, where all existing tools and techniques what you have mentioned, like TensorFlow or your NumPy or anything, will automatically will be explored, exported to other paradigm as well.
Yes.
Okay.
Moore's law was also failed nearly 5 years back.
Yes, definitely. I think maybe another few years this MATLAB and all nobody will use. I think even now the people have stopped using it because a lot of functions and libraries are available in Python. So definitely whatever the features we find in right now in these Python platforms and all, so it will be shifted to quantum computing altogether. The functions, libraries, everything will be written as new, which best suits for a new paradigm. Maybe some researchers, because the Google Minds and all, they always think of research. Hopefully they come out with such a computing paradigm very soon. Sure, what your idea is correct, really true.
Thank you.
Yes, sure, 100%.
Hi sir, good evening. Myself Aisha. I would like to ask regarding the gate data sets. Where can I get, or if you have to create it?
No, madam. Gate data set, Cassia B, Cassia C, all those data sets are available. Okay, I think in that presentation I have mentioned actually. Yeah, madam, she interacted with me and she shows no interest in carrying out. Yes, madam, the data set is freely available. Chinese gate data set. Okay, Cassia A, B, C data set is available, and even other data sets are also available, which you can freely download and you can conduct your experimentation. But you can design algorithms and you can study those algorithms for that data set. But apart from that, you can also create your own data set. Because in our research work, our research scholar has created some such realistic data sets in his institution, and he experimented on that real data set. Okay, yeah, that you can definitely do.
So, yeah, regarding creating the data set, we need the equipments. I think it's something different.
Yeah, only thing
here is it available somewhere where?
No, madam. That experimental setup you have to do.
Yeah,
right. You have to do. I think it requires just a good camera.
Yeah.
Okay, and you can see what could be the resolution that you can capture by placing the camera at a distance, and you can allow.
I think some variable sensors are also available.
No. You just have to decide whether you are going to use the sensors or you are going to use a simple camera based, right? Because there's a two different domain of research. So glow based, sensor based, and pure vision based, right? Because the vision based offers many advantages because you cannot expect an intruder, right? Wear gloves or something like that. He will come as a casual user, right? For example, if this is the restricted area, okay, so I have trained my machine, I have designed a system where it can recognize the gait of each and every person who is getting into the campus, like RBI campus. Okay, RBI campus, only the enrolled people must get into the campus. For example, if any new person, right, is wandering around the campus and trying to get in, at the time the surveillance camera will identify that, oh, this is something in a new person or an intruder. It gives an alarm, okay, by just looking at the gate information. So that is the realistic data set. My suggestion to you is, what you can do is, initially you train your algorithm or propose some algorithms, and you can test your algorithm on some standard data sets and find out the accuracy. For example, if you are getting an accuracy more than what has already been recorded in the literature, then it is fine, you can publish. But at the same time, you see whether that algorithm works in real time for a realistic data set where you can train your students or your employees in a typical campus environment, okay, in a different instances, right? For example, a person comes in a normal shirt and pant, and sometimes he comes with a coat, and sometimes he comes with a backpack, and sometimes he comes with another bag holding in his hand. So definitely the walking style will be changed. So for all those variations, right, in real-time environment, whether my trained system will give a good result or whatever the results that I have claimed. If not, then definitely you have to retrain your system for that data set so that it works better. And if you do so, then your algorithm is much better than the algorithm which is already published or which has already been claimed. Okay, so that's how you can keep on adding that, and you can study a lot of issues, right? So even I don't think anybody else has studied what could be the distance. What could be the distance, right? For example, if I place a camera here, if the person is wandering somewhere at a distance of 20 feet or so, is it possible for me to accurately identify the gait of the person, right? That's really a challenging issue. And even with one camera, it's not possible, because if the person comes in this perpendicular direction, right, with the camera, then some of the gait information will be lost, right? It should be this angle only. Then other camera should be captured. So multiple cameras in a multiple orientation need to be kept, right? And images should be collected, and from which camera we got best images, that need to be real time. That should be selected in real time, and that should be studied. So still, till now, I don't think any deployable solution is there for a gate. Okay, so only in some restricted areas they have deployed, but still no such solution is proposed and which we can deploy in a real time something like traffic monitoring system or other systems which you have already seen, right? So a lot of scope. Yes. Yeah. Okay. Very nice. Exactly. So particularly this is used in a very restricted areas like borders, army and all, and reserve bank. So any restricted area for that matter. Okay, bank premises and all. So really it's a very interesting problem, but not many people have explored it. So definitely a lot of scope is there for you to do, because a lot of new techniques can also be explored to solve that problem, which has not yet been explored to my knowledge right now. Okay, so definitely you can do, madam. So you get those databases, first download it, get the database, study the algorithms. Later, parallelly you can create your own data set in real time, train, and then you can test it. Right, sure, thank you. So thank you very much for the interaction.
Thank you, sir.
Dear participants, I sincerely thank on behalf of Department of Computer Science today's resource person Professor Nagendra Swamy sir for presenting various aspects of medical image processing in depth with the illustrations. Both the sessions were very informative and interesting. Sir tried his level best to impart as much knowledge as possible in these two sessions. He explained in depth the need for sophisticated tools for the current scenarios, the techniques that address the current challenges, including convolutional neural network, transfer learning, random forest, SVM, etc. Then sir had thrown light on various key aspects of image analysis, followed by various publicly available data sets like DDSM, INBRES, BCDR and many more. After that, sir presented state-of-art literature highlighting the scope for the researchers in carrying out their research in this field. As a token of gratitude, I request Professor Sharmila Kumari Madam to present a memento to Professor H.S. Nagendra Swamy sir. Thank you, sir. Now we will have a short tea break. After the tea break, we will assemble in lab. Our volunteers will escort you to the lab after the tea break. Before that, please scan that QR code for the attendance. It's today's attendance. Okay. Thank you.